Hello, good evening, students. Welcome to Extramarks. Myself is Extramarks. Myself is Mathematics Sudhakar. I teach mathematics here. We all know that fourth session is going on. Fourth session is going on. We conduct today. JEE Main. We conduct fourth session. JEE Main. Fourth session. First shift is conducted already. First shift is conducted. So I will give you complete analysis. So I will give you complete analysis on today's paper. JEE Main paper. On today's paper. JEE Main paper. See. So please share and subscribe our YouTube channel and press the bell icon. You will get notify the videos whenever we upload videos. You will get to know, right? So this is, we will give you complete analysis on this paper. We'll see first subject wise analysis. After that I will give you complete analysis on mathematics, right? So here in Extramarks we have expert faculty team. So myself is Ratakonda Sudhakar. I teach mathematics here, and Gautam sir is there to teach physics, and Kishore sir is there to teach chemistry. See, according to me, the maths paper is moderate to difficult, but it is lengthy, right? It is moderate paper, but it is lengthy. According to the physics, Gautam sir, the paper is easy to moderate, and according to chemistry, Kishore sir, the paper is easy to moderate, right? So we will give you subject-wise analysis now. You can see here difficulty level of the paper of mathematics. You can see they given 53% questions are easy, and 33% questions are moderate, and only 14% questions are difficult. This is the difficulty level of analysis of the mathematics paper. Now we'll see questions related to the mathematics. So these are memory based questions. We got these questions from our beloved students. So this may or may not be same as the actual question, but the concept behind the questions is same, right? So we'll discuss these questions one by one. The first question, the question is given from it is a locus. It's related to the concept of locus, right? So we will find the locus of, they given the condition, the sum of the squares of the distance of a point P from 0, 0, 0, 1, 1, 0 and 1, 1 is 18, and its locus is a circle. If D is the diameter of the circle, then value of D square is. That is the question. Now we'll see what is the equation for this statement. Sum of the squares of the distance of a point P. So let P is taken as P of x comma y. Right. This is the variable point moving on the plane. Now they given that the sum of a squares of distance of a point P from the points, 4 points they given 0, 0, 1, 0, 0, 1, 1, 1. Right. So the corresponding equation for this statement is, you can write like this: sum of the squares. So distance is PA. So if let it be, this is A, and this is B, and this is C, and this is D. I am named as ABCD. 4 points named as ABCD. Now they given that sum of the squares of the distances. What is the distance first? So PA is the distance from point P to the point A. So that is the distance PA. They given PA square. Right, sum of the squares. So that means squares, PA square, PB square. So we have to add all these things. That is the sum of the squares of the distance of a point P to ABCD. So PA square plus PB square plus PC square plus PD square equal to, they given that 18. Right? It is equal to 18. Now PA square, what is P is, we assume that it is x comma y. What is A? A is 0, 0. So what is the distance? I am finding separately first. What is PA square? Right, PA we know that square root of distance between the 2 points formula, x2 minus x1 whole square plus y2 minus y1 whole square. Right. So here the x2 minus x1, one point is x comma y, another point is 0, 0. So what is the distance? X minus 0 whole square, y minus 0 whole square. Right. So this is the distance between these. So if you do squaring, because we require PA square, square root gets cancelled out with the square. So we left with x square plus y square. Similarly, we can find the value of PB square, PC square, PD square. Right. So this is the PA square. Now similarly we will find PB square. So what is the PB square? It's the distance between P and B, and apply square for that. So when you apply the square root gets cancelled out. Now, so what is the PB square? 0, 1 is B 0, 1. So P is x, y, B is 0, 1. So this is x minus 0 whole square plus y minus 1 whole square. So if you simplify this, you will get x square plus y square, y minus 1 whole square. Right? So third one is PC square. What is the PC square? PC square is P is x, y and C is 1, 0. We have to find the distance between them. So 1, 0, x minus 1 whole square plus y minus 0 whole square equal to x minus 1 whole square plus y square. Right? So now last one is D. The point is D. So PD. D is 1, 1. D is 1, 1. So D is 1, 1. P is x, y. The distance between PD is so x minus 1 whole square plus y minus 1 whole square. See, PD means square root will come. PA, PB, PC, PD. Square root will come, but due to square, the square root gets cancelled out with square. That's why I am not written square root. Right? PA square means without square root we have to write. Now we have to add this. So if you simplify this, you will get this only. So this is x minus 1 whole square. So there are 4 terms, 4 equations. We have 4 equations. We have to add all these 4 equations because they given sum of the squares of distance of a point P from the 4 points is equal to 18. Right? So now I am adding all these things. So this is first equation, second equation, this is the second equation and the third equation. This is the fourth one. So I am adding 4. So that is the value PA square plus PB square plus PC square plus PD square equal to 18 they given. So it is equal to 1 plus 2 plus 3 plus 4 equal to 18. So what is 1 here? X square plus y square. X square plus y square. Similarly PB square is x square plus y minus 1 whole square plus here x minus 1 whole square plus y square. This one, last one is this. Last one is x minus 1 whole square plus y minus 1 whole square. So this value is equal to 18 they given. This is equal to 18. Now we have to simplify this. X square, there are 2x square, y square, 2y square. Right, and then 2 times of x minus 1 whole square, 2 times of y minus 1 whole square. Every term repeated twice. So that's why I am simplifying this. X square plus y square, right, I am taking 2 common, and x minus 1 whole square plus y minus 1 whole square equal to 18. If you simplify further, what you will get? You will get this 18 gets cancelled out. 18 gets cancelled out by 2. Right, 9 times. So we left with x square plus y square. I am expanding this. X square plus minus 2x plus 1 plus y square minus 2y plus 1 equal to, whenever 2, right, so 2 cancel with 18, they will get 9 here. Right, here 18, whenever 18 divided by 2, we will get 9. So now if we simplify this, we will get x square, 2x square, y square, 2y square. Right, so this is 2x square, this is 2y square, and then so we will get, every time we will get 2 common again. You can see here 2 common. When I am taking 2 common, you will get x square plus y square, and this is minus 2x, so minus x, minus 2y minus y. So here plus 1 plus 1 plus 2. So 2 already taking common, it is 1. It is equal to, this is equal to 9. Right. So it is equal to 9 by 2. So we left with x square plus y square, x square plus y square minus x minus y plus 1 is equal to 9. So 2 shifted to that side become 9 by 2. So this become 9 by 2. So if I cancel this 2 here, you will get 9 by 2. It's 9 by 2. Right. Now we have to, this is the equation of a circle. Equation of a circle. So 1 minus 9 by 2. You will get minus 7 by 2. The constant is minus 7 by 2. This part, if you simplify that, you will get minus 7 by 2. So is equal to 0. Right. Is equal to 0. So this is the equation of a circle. Then what is the radius of this circle? Root of g square plus f square minus c. Root of g square plus f square minus c. What is the center? The center is clearly 1 by 2, 1 by 2. And this is constant c is minus 7 by 2. So the formula is square root of g square plus f square minus c. G square plus f square minus c. So what is the, so root of g square plus f square minus c is the radius, right? So this is equal to 1 by 4 because 1 by 2, 1 by 2, 1 by 4 plus 7 by 4, right? This is 1 minute. This is 7 by 2, 7 by 2, right? Now what we will get here, if we simplify this, we will get, this is 7 by 2, sorry, this is 7 by 2. Simplify this, you will get 1 by 2, 7 by 2, 8 by 2, it is equal to 4. Square root of 4 is 2, it is equal to 2, but this is the radius. What is the diameter? Diameter is 4. Whenever radius is 2, diameter is 4. Diameter is 4, then they are asking d square value, it is equal to 16. So the answer is A for this question. Answer is A, right? Understood? Now we'll see the next one. So this is the question from the vector algebra. We'll see they given A given, B given, and A cross C is equal to B given, A dot C is equal to 3. And they are asking us the value of box ABC. We all know that box ABC, if you expand the box ABC, this can be written in two ways, A cross B dot C, right? Or we can write A dot B cross C. We can write in two ways, this one, right? But they are not given either A cross B, right? A cross B we can calculate, but we don't know C. We don't know C, right? So here B cross C. If you want to find B cross C, C is not given. That's why, so we will get the answer in the simplify, very easy if you do like this. See, box ABC can be written as, this is equivalent expression of box ABC is, so right, I'm cyclic order, so shifting the terms by 1 unit. So BCA, you can write it as BCA, right? BCA, you can write this is BCA, or you can write it as CAB. You can write it as CAB. Now what they given here, if you write B dot C cross C or B cross C dot A, right, we don't have C, right? Now what I am doing here they given A cross C value, we will use this A cross C, this result, we use this result. If you use this CAB, I am using the box CAB because these three are equal, so I can write this equal to this, right? So box CAB equal to what you can write, C cross A dot B, C cross A dot B, right? What is C cross? They given A cross C. If C cross A, if write in terms of A cross C, then it is minus A cross C, right, dot B. Now what is A cross C? They given value, it is B bar, right, vector B bar. So minus B bar dot B bar. So if you multiply this dot product, if you do dot product between the two similar vectors, then it is square of its magnitude, mod B square, right? Mod B square is the answer. Now we have to calculate B value. What is the B value here? What is the B value? B is vector B is given that I cap minus K cap. I cap minus K cap. What is the magnitude of B? Magnitude of B is 1 square plus 1 square, right? 1 square plus 1 square. So if you simplify this, you will get root 2. If you simplify this, you will get root 2. So this is mod B square, mod B. So whenever it is mod B is root 2, it is square of that. Square of that it is 2. So minus is there outside. So answer is minus 2. First option is the right answer for this question. So if you do like this, you can get the answer within 1 minute, right? Within a minute you can get the answer. But you can get answer if you do like this. Either if you are using the formula A cross B dot C or A dot B cross C. Let C is equal to xi plus yj plus zk. You can consider any vector and we are finding the values of x, y, z. After that, right, so we are substituting in the value of in the vector C. After that we will find the box ABC. But it takes time 2-3 minutes. So if you do like this, you can get the answer within a minute, right? Now I'll see the next one. So this is the question from the circles and combination of circles and parabola. So the given circle center at minus 15, 0 and radius is 15 by 2. Let the chord of a circle passes through the point minus 30, 0. And tangent to the parabola y square is equal to 30x. then the length of the chord is, that is the question. Length of the chord is, we all know length of the chord of the circle is 2 root of r square minus d square. You know, length of the chord of the circle. If this is the circle, then this is the chord. The chord, the formula is the center of the circle. This is center of the circle. So this is the distance, perpendicular distance from the center of the circle to the line. It's a chord, right? So this, the formula is 2 root of, this is d, perpendicular distance, and this is the radius r. The formula is 2 root of r square minus d square. Right, this is the formula. 2 root of r square minus d square is the formula. This is the length of the chord. Length of the chord. Length of the chord. But we have to find the values of r and d. Now, they given here, they given a circle, information given that circle centered at minus 15 comma 0 and radius is 15 by 2. Radius is 15 by 2. Let the chord of a circle passes through the point minus 30 comma 0 and it is the tangent. The chord is a tangent to the parabola. So we have one formula. Whenever the given equation, it is the standard form of the parabola, y square is equal to 4ax. Then the equation of the tangent to the standard form of the parabola y square is equal to 4ax is y is equal to mx plus a by m. So using that formula, we can find the value of m. Right. Now I'll see this. They given circle centered at minus 15 comma 0 and radius is 15 by 2. Radius is 15 by 2. So now I am using the concept equation of tangent. What is the equation of tangent? Equation of tangent to the parabola y square is equal to 4ax. In the slope form is y is equal to mx plus is y is equal to mx plus a by m. Y is equal to mx plus a by m. This is the formula. So we can use this formula. Now they given this is the tangent. They given chord is the tangent to the parabola. Y square is equal to 30x. Right. So y square is equal to 30x. Now I am comparing this. So with y square is equal to 4x. 4a is equal to 30. A is equal to 15 by 2. A is equal to 15 by 2. Now I am substituting this value here. Y is equal to mx plus 15 by 2. So 15 by 2m. A value 15 by 2. Now they given another information. This tangent is also passes through the point minus 30 comma 0. It passes through the point minus 30 comma 0. Right. So it passes through the point minus 30 comma 0. That means what? It is the x coordinate and this is the y coordinate. So this point must satisfy the line because this line passes through the point. So substitute y is equal to 0. If you substitute y is equal to 0, you will get 0 is equal to m into minus 30. So minus 30x, sorry, minus 30m, and this is plus 15 by 2m. 15 by 2m. Right. So now we can get the value of m from this. What is the value of m? 30 is equal to, so this, if you simplify this, you will get 60m, right, 60m square you can take. 60m square is equal to 15. Can get like this because 30m shifted to this side and 2m shifted to this side. Now m square is equal to 1 by 4. Right, m square is equal to 1 by 4. So there are two values for m, plus or minus 1 by 2, but we will consider any one of that. We will consider 1 by 2. We will consider 1 by 2. Then we will, because there are two tangents to the parabola, having two slopes. One is the positive slope, positive off, and one is the negative off. We will take the positive off and we will use the another information. Right, here they given circle centered at minus 15 comma 0, radius is 15 by 2. Right, now I am drawing the circle. So this is the chord. Let it be this is the chord, and the chord is what? You can substitute m value here. You will get the equation of the line. Y is equal to m is off. That means x by 2. Here 15 by 2m. So m is equal to off, 2m is equal to 1. So 15. This is equal to 15. So this is the equation of the chord. This is the equation of the chord. Right. Now, so what I have to find? Just now already we saw the formula. What is the formula here? 2 root of r square minus d square. 2 root of r square minus d square is the length of the chord. Right. So already they given radius is 15 by 2. Radius is 15 by 2. R is equal to 15 by 2. Now our aim is finding the value of D. What is the D? Distance from center of the circle to the line. That is the D. So what is that? D is equal to, how to find D? You can see the perpendicular distance. What is the perpendicular distance formula? Perpendicular distance from point to the line is modulus of ax1 plus by1 plus c by root of a square plus b square. So we use that formula here. So what is the perpendicular distance? D is equal to modulus of ax1. What is center here? What is the center of the circle they given? Minus 15 comma 0. So we use that minus 15 comma 0. So I am finding, this is the minus 15 comma 0. So I am finding the distance from point to the line. This is the point and this is the line. So using the formula, distance formula, right? My x by 2 minus 15 by 2 minus 15 by 2 minus 1 into 0 is 0 plus 15 divided by square root of a square plus b square. That is 1 by 4 plus 1. 1 by 4 plus 1. Minus 15 by 2 plus 15 is equal to 15 by 2. So numerator is 15 by 2. Numerator is 15 by 2. And denominator is, you can see here 4 plus 1. Root 5 by 2. Root 5 by 2. Root 5 by 2. 2 gets cancelled out. We left with 15 by root 5. 15 by root 5. Right. 15 by root 5 can be simplified. 3 root 5. Right, this is equal to 3 root 5. D is equal to 3 root 5. So this is the value of D. So what is the formula? Length of the chord. Length of the chord is 2 root of r square minus d square. I am using here. So 2 root of r square. R square is what? 15 by 2. 15 by 2 whole square is 225 by 4 minus d square. What is the d square? This is, you can see here, 3 root 5. 9 into 5. 9 into 5. 9 into 5 is 45. So simplify this, 2, you'll get 3 root 5, 15 by root 5, you'll get 15 by root 5, 15 by root 5 and this is 2. So 2 gets cancelled out. So this is equal to 3 root 5. Again it is 3 root 5 only. So the answer is 3 root 5. First option is the right answer. Right. First option is the right answer. Right. So using the single formula 2 root of r square minus d square and using the formula of y is equal to mx plus a by m, we can get easily this one, right? It's very simple question. Now I'll see next one. This is the question related to the ellipse, right? So they given tangent at P, the P lies in the second quadrant. P lies in the second quadrant and which is perpendicular to the line x plus 2y is equal to 0. Then the value of 5 minus e square into area of SPS dash. They given eccentricity. E is the eccentricity and S and S dash are the foci of the ellipse. Right. So they given the point lies in the second quadrant. This is the ellipse. Clearly you can see a square. When you compare this equation with x square by a square plus y square by b square equal to 1. Clearly a greater than b. So whenever a greater than b, so the ellipse is horizontal ellipse. Ellipse is horizontal ellipse, right? So the ellipse will be like this. Ellipse will be like this. Now the point they given that it is in the second quadrant. The point lies in the second quadrant, right? Tangent at P. So we have to draw the tangent at P like this. Now they given that it is perpendicular to the line x plus 2y is equal to 0. So what is the slope of the tangent? Yeah, so you have to find the slope of the line x plus 2y. The slope of the line x plus 2y is minus 1 by 2. Minus 1 by 2. So this is perpendicular. Tangent is perpendicular to this. For example, this is the line. We assume that this is the perpendicular. Tangent is perpendicular to this line x plus 2y is equal to 0. Right. So we know that M1, M2. So if two lines are perpendicular, the product of their slopes is minus 1. So now if the slope of this line is minus 1 by 2, the slope of this tangent must be 2. The slope of this tangent must be 2. Right. And we must remember whenever they given standard ellipse, standard horizontal ellipse is given, at that time we need to remember the formula, equation of the tangent to the ellipse. Equation of the tangent to the ellipse. And we will take this point is P of x1, y1. P of x1, y1. Right. Now I'll see equation of the tangent to the ellipse. Equation of the tangent to the ellipse. Equation of the tangent to the ellipse. Equation of the tangent to the ellipse in the slope form. Y is equal to mx plus square root of a square m square plus b square. This is the formula we have, right? So this formula we use this formula to find the value of m, to find the value of, right, to find the point on the line, to find the point P on the line, on the tangent. So how to find? Using the formula. I'll see now. So this one, this is the tangent equation, and this is the tangent equation. This is the tangent equation in terms of slope, and this is the tangent equation in terms of line we will have to find. In terms of line we have to find. And first we have to find the eccentricity. What is eccentricity or eccentricity? Here, eccentricity, whenever they given standard parabola, horizontal parabola is given, the eccentricity is a square minus b square by a square. This is the formula we have, right? So what is the a square? When you compare this equation with this equation, you will get a square is 8, b square is 4, right? So 8 minus 4 by 4. So this is equal to 8 minus 4 by 4. 4 by 4, right? That is equal to 1. E is equal to 1, right? A square minus b square by a square. Sorry, this is 8. Mistake here, this is 8. This is 8. So this is 1 by root. It should be 1 by root. It should be 1 by root. Now we got eccentricity. Now we have to find eccentricity. We can calculate this value. Now what about the area of SPS dash? How to find the area of SPS dash? See, the SPS dash, the point is here, SC, this is S and this is S dash. You know the formula is AE comma 0 minus AE comma 0. Minus AE comma 0 and this is AE comma 0. So plus or minus AE comma 0. And this distance is 2AE. This distance is 2AE. Now how to find the area of this triangle? This is the point. So this is the point. So area of this triangle. This is not right angle triangle. This is not 90. This is not 90. Right, the point is moving point. Moving point, it lies in the second quadrant. So we have to find the area of the triangle SPS dash, right? SPS dash is, you can use the formula of into base into height. Base we have, the base length is 2AE. But what is the height? How to find the height of this length? Height of this triangle. Height of this triangle is equal to the y coordinate. Because the point, the distance from point to the x-axis, this is the x-axis, major axis is the x-axis, and minor axis is the y-axis, because it is a standard ellipse, right? So we have to find the area of the triangle. We have already base, and we need to find the height of the triangle. Height of the triangle equal to the y coordinate, magnitude of the y coordinate of the point, right? Now how to find the point P? We have to find the point P and we have to find AE value. So AE value, because we require 2 AE. AE value, AE is already, A square is 8. What is AE? AE is 2 root 2. Right. A square is equal to 8. If A square is equal to 8, then A is equal to 2 root 2. So 2 root 2 into 1 by root 2. That is E value. So root 2 gets cancelled. AE is equal to 2. AE value is equal to 2. Right, AE value is equal to 2. Now we have to find the point, coordinates of the point P. How to find the coordinates of the point P? How to find the coordinates of the point P? Just you have to use this formula. What is y is equal to mx plus or minus root of a square is 8. 8m square plus b square is 4. They given 4. Right. Now they given, we have m value also. They given m value, this line slope is minus of, then this line must be, the slope of the tangent must be 2. So this is m is equal to 2. So y is equal to 2x, this is 2 square 4 into 8, 32 plus 4, 36. This is 36. So y is equal to 2x plus 6. Now we have to find the equation of the tangent in the point form. Then we can compare and we can find x1, y1. So what is the point form? What is the equation of the tangent in the point form? Equation of the tangent in the point form, xx1. So this is xx1 by a square plus yy1 by b square is equal to 1. Right, xx1 by a square. Now we have this equation. This equation also need to be put in that form, right? So how to put? So I'm dividing with 6. I'm shifting this 2x to this side. So y by 6 minus x by 3 is equal to 1. Right, I am shifting this 2x to this side and dividing with 6 on both sides so that this form and this form are in the same form, right? These two equations are in the same form. So now x coefficient is x1 by 8 and here x coefficient is minus 1 by 3. So x1 by 8 is equal to minus 1 by 3, right? Now we can get x1 value. x1 is equal to minus 8 by 3. Similarly, y value, y1 by 4. What is the y coefficient here? Y coefficient is y1 by 4. y1 by 4. So y1 by 4 equal to y coefficient here 1 by 6. So y1 equal to 2 by 3. x1, y1. We have the values x1, y1. But we required only y1 because we required height of the triangle. The height of the triangle, the distance from point to the x-axis, y coordinate, magnitude of the y coordinate. Magnitude of the y coordinate. Right, so y coordinate is what? 2 by 3. 2 by 3. So now, this is the height. Now what is the area of the triangle? Area of the triangle. What is the area of the triangle? Half into base into height. Half into base is what? Base is equal to, can see here, base is, AE is 2. 2AE, 4. So base is 4. Into height. Height, just now we calculated y coordinate. Height, this is equal to height. Height of the triangle. Right, 2 by 3. Now, this is 2 by 3. So, 2 gets cancelled out. This is a 4 by 3. So, area of the triangle is 4 by 3. This value is 4 by 3. And what about this value? 5 minus e square. What is e? 1 by root 2. 5 minus 1 by 2. So, 5 minus 1 by 2. 5 minus 1 by 2 is 9 by 2. So, 9 by 2 into 4 by 3. 9 by 2 into 4 by 3 is 6. Right? That is the answer. 6 is the right answer for this question. Understood? Now we'll see the next one. This is the question from the integration. See, definite integration. Definite integration. They given two limits, a minus of 1 by root 2 to 1 by root 2, x minus 1 by x plus 1 whole square plus x plus 1 by x minus 1 whole square minus 2. If you observe closely, here you can see the inner one is in the form of a square plus b square minus 2ab. We can write this minus 2 into ab because these two terms gets cancel out, right? Inner terms gets cancel out. That's why we can write like that. So this is, they given a minus b whole square form. We can write this expression like this: x minus 1 x plus 1 minus x plus 1 by x minus 1 whole square with square root. They given square root. 1 by root 2, 1 by 2 means square root. These two terms gets cancelled out. But remember that when you square and square root gets cancelled, this is not x always. This is x only whenever x is positive. This is the mod x. So that's why this should be mod x. Right, this should be mod x. X minus 1 by x plus 1 minus x plus 1 by x minus 1. So this is the modulus. That limits coming as it is. Integration sign and my limits coming as it is. Right. Now simplify this. X minus 1 whole square minus x plus 1 whole square. This is minus 4ab by this is x square minus 1. But due to this symbol, right, modulus symbol, this become 4x only. 4x by x square minus 1. 4x by x square minus 1. This limits coming as it is. Minus 1 by root 2 to 1 by root 2. So this is 4x by x square minus 1. Right. Integral minus 1 by root 2 to 1 by root 2. So this can be written like this. Because it is even function. Mod x is even function. We know that. That's why we can write 2 times of 0 to 1 by root 2. This one is 4x by x square minus 1. 4x by x square minus 1. But remember one thing. In the interval 0 to 1 by root 2. In the interval 0 to 1 by root 2. 1 by root 2 value is 0.7 something. So 0.7. Take some any value which lies in the interval 0 to 0.7. Let it be 0.5. Substitute here. What you will get? Negative. We are getting the negative value inside the modulus. Whenever you are getting negative value inside the modulus for the given limits, so you have to put minus sign. Remove the modulus sign and put the minus sign. Right. So this can be written like this. 0 to 1 by root 2. And this is replaced by minus. 4x. That minus I kept outside. 4x by x square minus 1 into dx. Right. So dx is coming as it is. dx. So now we have to simplify this. We have to find this value. 0 to 1 by root 2, 4x by x square minus 1. If you observe closely here, take here 2 common. It become 4. And we left with 2x divided by x square minus 1. You can see here, this is the differentiation and this is the function. This is the differentiation of f of x and this is the f of x. So f dash of x by f of x is log mod f of x. So minus 4 log mod f of x. Log mod f of x is x square minus 1. So keep the limits. What are the limits? 0 to 1 by root 2. So when you put the limits, so this become x square. 1 by root 2 become 1 by 2 minus 1. So we will minus 1 by 2. Due to modulus sign, it become 1 by 2 only. So log 1 by 2. Log 1 by 2 minus log 0. Log 1, it is 0. So we left with, so when you can write log 1 by 2 can be written as 2 power minus 1. That minus will come to front side. So it becomes 4 log 2. So this 4 log 2 base C can be written as 4 ln 2. 4 ln 2. So the answer is 4 ln 2 is the right answer. Option D is the right answer for this question. Understood? So this is again, it's a little bit moderate question. So you can do like this. I hope you understood this. Now we'll move to the next one. This one. ln of x plus y is equal to 4xy. Then the value of d square y by dx square at x is equal to 0. Right. So here you have to convert this logarithm form to exponential form. You have to do double differentiation. Double differentiation. So I can write this x plus y is equal to e power 4xy. This form ln of this can be written like this. Now you have to do double differentiation. Now we have to find the value of x and y. They are given x is equal to 0. Whenever x is equal to 0, y is equal to, what you will get? Y is equal to 1, clearly. Now differentiating on both sides. When you differentiating on both sides with respect to x, differentiating on both sides. Right, with respect to x. Now you can see this differentiation of x is 1, differentiation of y is y dash, and differentiation of e power 4xy is e power 4xy into 4 times of right xy dash plus yx dash, that is 1. So this is the one value of the differentiation of e power 4xy. Now again we have to differentiate. Right, before doing differentiation we have to find the value of y dash, because we will use this y dash value later. So how to find the y dash value? Substitute x equal to 0, y is equal to 1. So y is equal to 1, this become 1 plus y dash is equal to e power 0, 1, and this is 4 times of x is 0, y is 1, so it is 1. So this the value, y dash value is, what is the y dash value here? Right, this is 4 minus 1. Y dash is equal to 4 minus 1 is 3. The y dash value is 3. Now we have to do double differentiation for this equation. 1 plus y dash equal to e power 4xy, 4 times of xy dash, 4 times of xy dash plus y. So take that one and do double differentiation. If you do double differentiation, you will get y double dash, 1 differentiation 0, y dash double differentiation is y double dash, e power 4xy into this. So 4 keep outside, e power, keep the bracket, e power, I am applying UV rule, u into v into v dash plus v into u dash, e power 4xy, right as it is, and differentiation of this xy dash plus y, again you have to apply product rule again. Xy dash is xy double dash, y dash into x, right, plus y differentiation is y dash, this is the differentiation of this xy dash plus y. Now I have to differentiate this e power 4xy, so this part you have to write as it is, xy dash plus y, right as it is, and e power 4xy differentiation e power 4xy into the differentiation of e power 4xy is 4 into xy dash plus y, right. So this will get. Now if you simply put values of x, y and y dash, these 3 values, if you keep x and y dash values, if you kept in this equation, you will get y double dash is equal to 40. So this is the answer for this question. 40 is the right answer for this question. 1 minute. Here s is 0. It is 0. Yes, correct. It is 40. So 40 is the right answer for this question. Understood? Now I'll see the next one. So this is the question from the binomial theorem. This is very a good question. Sigma r square into 20 CR. So it's very simple question, right? If you do like this, r square. So I'm writing this sigma, keep as it is. R square written as r into r, 20 CR. Now I am adjusting the term 20 CR like this, 20 by r into 19 CR minus 1. You can write this 20 CR like this. Now you can see clearly RR gets cancelled out. So now we left with 20 constant, you can keep outside, sigma r into 19 CR minus 1. Now we need to remove this r minus 1. To remove this r minus 1, right, I need to change this r. Right, how I can change? I am adding and subtracting. So I am adding and subtracting plus and minus 1. R plus 1. So what is I required? I required minus 1. Right, I required minus 1. So I need to put minus 1 and plus 1. So it is, the next one is 19 CR minus 1. 19 CR minus 1, right as it is. I am adding minus 1 and plus 1. Now I am simplifying this. 20 sigma. This one can be written as 2 sums. 2 sigma. I can put the 2 sigmas. Right. Divide this into 2 terms. R minus 1 into 19 CR minus 1. Minus or plus 1. 1 into this. So 19 CR minus 1. So I am keeping sigma here also. Sigma of this and sigma of this. So we have, if you put sigma r is equal to, this is r minus 1. You can write again here r minus 1 into, this can be written as 19 by r minus 1 into 18 CR minus 2 plus this value, right as it is, 19 CR minus 1 sigma. Now this you can see here, this is r minus 1. This is r minus 1. R minus 1 gets cancelled out. We left with 90. So this 20 is common for all. So 19 into sigma 18 CR minus 2 plus sigma 19 CR minus 1. Right. So whenever r lying from 2 to 8, 20. R lying from 2 to 20 because n is 20. Right. So at that time you will get r lying from 2 to 20. Here r lying from 1 to 20. So at that time what you will get here? The value 20 times 19. This value is, if you put 2, you will get 18C08 plus 18C1 like that. So it is equal to 2 power 18. Right, 2 power 18. This value is 2 power 18 and this value is 2 power 19. So this is the answer. So 2 power 18. If you simplify further, you will get 2 power 18 common, 2 power 18 common, 2 power 18 into 2. 2 power 18 into 2. It is 2 power 19. And then you can see here 19 plus 1. Right, 19 plus 1 is 20. Understood? So we will get 210. 210 into 2 power 19 is the right answer for this question. Right? Understood? It's very simple question if you do like this. You have to split this r square into r into r. Right? After that cancel r and again we have to cancel r minus 1. To cancel r minus 1, I am adding minus 1 and plus 1. Again I am cancelling r minus 1. Right? This is the easiest method to solve this problem. Now see the next one. This is the question on area. Finding area of the, they given two inequalities. Right? Two inequalities. We have to find the area of this boundary region formed by these two inequalities. 3x square less than, first we will split this. 3x square less than or equal to 4y. And then you can write 4y less than or equal to 6x plus 2y. Right? 6x plus 2y. Now this one, if you can take equal to sign and solve them first, where they are intersecting. These two curves are intersecting at some point. We have to find the intersection point. 3x square is equal to 4y. To find intersection point, take the equal to sign. 4y, this is 2y. Shifted to this side become 2y equal to 6x. So this is equal to 3x. Y is equal to 3x. Substitute y is equal to 3x here. 3x square is equal to 4 into 3x. So 3 gets cancelled out. X square is equal to 4x means x is equal to 0, 4. So this is the x values where at this x values the two curves are intersecting. Right, now we will plot these curves on the coordinate plane. Now we'll see what is the curves of these equations. 3x square less than 4y. Let it be 3x square is equal to 4y. This can be written as x square equal to 4 by 3y. So this is the parabola, upward parabola. It will be like this. This is the upward parabola. Right, another one is they given that y is equal to 3x. Y is equal to 3x, the line passes through the origin like this. Now we have to find the area of these two curves, common area, but they given inequality sign, not equal to sign. Inequality sign is given right in the two equations. Now how to identify the area of this inequality? See, it's very simple. For example, if I am taking this line, this is 2y is equal to 3x, y less than or equal to 3x. This is the given line after simplifying. Now y less than or equal to 3x means takes origin. Origin is satisfying here. Origin y is equal to 3x. Put y is equal to 0, x equal to 0. Y is equal to 0, x equal to 0. It is, what is this? This is 0 less than or equal to 0. That is wrong. 0 less than or equal to 0, it is correct because with maybe less than or equal to. So 0 is satisfying. Now I am taking another point. Let it be 0, 0 is satisfying for this inequality. Let it be the point 0, 5. Right. I am substituting 0, 5. 0, 5 is satisfying. You can see clearly 0, 5 means 0. X is 0, y is 5. 5 less than 0. 5 less than 0 is wrong. So 0, 5 is somewhere else here. This point 0, 5 is not satisfying by the line. That means the line, this is the one-sided line. So this is the region. This is the region. That line, right? This line specifying this region, one side of the line. Now we will see the region of this curve. What region it representing? You can see to identify the region of this curve. So you have to take same thing. You have to take some point. The equation is 3x square less than or equal to 4y. Take 0, 0. It is satisfying. Now we'll take another point. Let it be 0, 5 only. 0, 5. 0 less than 5. Yes, it is satisfying. Means inner region. This region, entire region, it is satisfying. So what is the common region? So it is satisfying inner region of the parabola. Inner region. Inside of the parabola. So the common region is this only. This is the common region. This is the common region which satisfying at a time. Right, common region. So we have to find the area of this. It's very simple using the integration 0 to 4 because it is intersection point. It is intersecting at 0, 4. Now upper curve minus lower curve. Use the formula upper curve minus lower curve. What is the upper curve here? Straight line. And lower curve is parabola. Lower curve is parabola. What is the straight line? Y is equal to 3x. So 3x, this 3x minus upper curve is 3x square by 4. 3x square by 4. Right. So if you integrate this, integration is very simple. After that, substitute the upper limit minus lower limit. So if you do like that, you will get the answer. Answer is 8. Clear? So this is very simple question based on area of the two curves, inequalities. Now I'll see the next one. This is the question related to the concept of probability. So P of A is P and P of B is 2P. P of exactly one of A and B occurs is equal to 5 by 9. Then the maximum value of P is, that is the question, maximum value of P is. See, we have to, first we have to solve this part. P of exactly one of A and B occurs. What is mean by that? So exactly one occurs means this is can be written as P of A intersection B bar plus or P of A bar intersection B. Right, we can write because exactly one is occur. A intersection B bar or A bar intersection B is equal to 5 by 9. That is the given. So this can be written as P of A minus P of A intersection B plus P of B minus P of A intersection B. So this is the formula for this P of A minus P of A intersection B. For this the formula is P of B minus P of A intersection B is equal to 5 by 9. This is equal to 5 by 9 they given. So you can see 2 times repeated A intersection B. So this can be written as P of A plus P of B minus 2 times of P of A intersection B is equal to 5 by 9. Right. So P of A plus P of B. What is P of A? P of A plus P of B minus P of 2 times of P of A intersection B is equal to 5 by 9. They given P of A is P. P of B is 2P. So this is P, this is 2P, this is 3P total. Minus 2 times of P of A intersection B equal to 5 by 9. Now we can see the range of A intersection B. The range of A intersection B. I am drawing two circles. One is representing A, another representing B. And this is the universal set. This is the two sets under the universal set. you can see what is the minimum value of A intersection B? Minimum value whenever the two circles are not overlapping, at the time it is 0, intersection is 0. So the minimum value of P of A intersection B is 0. And then what is the maximum value? When it is maximum value, whenever two circles, one is completely lies inside, the intersection of these two is the smallest one, right? So what you can write? Minimum of P of A comma P of B. P of A comma P of B. Minimum of P of A comma P of B. Whatever is minimum, that is the common region, right? So that is the maximum of P of A intersection B. Now we can see this is, they given this one. This is equal to 5. We can write this as, this is value shifted to this side and this value shifted to this side. At the time I will get the P of A intersection B value 3P minus 5 by 9 divided by 2. This is the P of A intersection B value, and the minimum of P of A comma P of B is P only, because P and 2P, they given two values. So P and this is less than or equal to 0. Right? Now we have to simplify this. We'll get the value of P. So this is 0 and this is 3P minus 5 by 9 less than or equal to 2P. So 2P shifted to this side. So P and 5 by 9 shifted to this side. You will get P less than or equal to 5 by 9. The maximum value is 5 by 9. The maximum value is 5 by 9 is the right answer for this question. Right? Now I'll see the next one. This is the one. This is the very simple question based on infinite GP. What is the infinite GP? The formula infinite GP is A by 1 minus R. Whenever the given terms are like this, if the terms are like this, then the formula is A by 1 minus R. What is the formula for these terms? This is A square, like that. A square, R square, like that. So what is the formula? The first term, first term is A square by, and the ratio, common ratio is R square. Common ratio is R square. It is equal to, they given this value is 15 and this value is 150. And the third one, they are asking us what is the value of this. So S is equal to, first term is AR square divided by 1 minus R square. Right, the first term is AR square. So first term by 1 minus common ratio, that is the formula. Now it's very simple to find, easy to find by using division. Just do division, this by this. What you will get? A gets cancel out. You will get A in the numerator and 1 plus R. Because this can be written as 1 plus R into 1 minus R. You will get 1 plus R in the denominator. 150 by 15 is 10. So A is equal to 10 plus 10R. 10 plus 10R. So 10 plus 10R. So from this we can get the value of, substitute A value here. A by 1 minus R. A by 1 minus R is equal to 15, right? We have the value of A, 10 plus 10R. 10 plus 10R is equal to 15 minus 15R. 15 minus 15R. This 10 shifted to this side, 15 shifted to this side. 25R is equal to 5. R is equal to 1 by 5. R is equal to 1 by 5, and we can get the value of A. A is equal to 10 plus 10R. So A is equal to 10 plus 10 times of R. R is equal to 1 by 5. Right, R is equal to 1 by 5, it is equal to 12, right, 10R. So we got the values A and R, substitute here, you will get the answer. This is the simplified form of this. So the answer is 1 by 2, you will get 1 by 2, answer is the first option. First option. It's very simple question based on the single formula, infinite GP. So first term divided by 1 minus common ratio, that is the formula, right? We will see the next one. Number of 3-digit even numbers can be formed using the digits 0, 1, 3, 4, 6, 7 without repetition, right? That is the question. So we will divide it into 3 cases, 3-digit numbers. So we need to consider 3 blanks. So first blank, they give even numbers. They are asking even numbers. Even numbers means the number should end with even number. 0, right? 0, what are the numbers here? 4, 6. 0, 4, 6. Now I am keeping 0. First I am keeping 0 because I can't use the digits more than once. That's why what number of numbers I can place here, that you have to check. I am placing 0 here. I cannot use 0 again, right? So I left with 1, 3, 4, 6, 7. How many number of numbers are there? 1, 3, 4, 6, 7. 5 numbers are there. This is 5 times. So I cannot use the whatever I used the number here, right? I cannot use once again. So that's why this place can be filled with 4 times. I can fill this place by 4 times. So this is 20 ways. 20 number of numbers are there ending with 0. Again here the number filled with 4. When I filled with 4, I cannot place 0 here. I cannot place 0 at the first place. If you place 0, it will become 2-digit number. So this is only 4 times. Again, I can use 0 also. So again, also this is place also can be filled by 4 times. Right? You can fill any one of the four numbers. So this is can be done in 16 ways. 16 ways. Again similarly we can, if you place 6 here, we can fill these 2 places in 16 ways. So total, this is 32 plus 20, it is 52. Number of ways, number of 3-digit numbers, 52, whenever the number is ending with even number. Clear? Understood? We'll see the last one. This is in a hospital 89% has disease A and 98% has disease B. K% is the number of patients who has both. Then the range of K is, right? Then the range of K is. This is also again very simple question based on probability. Right, now we'll see what is the diagram for this. So this one 89%. Let U is equal to 100. U is equal to 100. Right. Now 89. So N of A is 89. N of B is 98. This is the given. Now what we have to do here? Here they are asking the value of the range of K. The range of K. K is the common thing. Now I am using the formula N of A union B. N of A union B, we know that this is the formula of N of A plus N of B minus N of A intersection B. N of A, they given 89. N of B is 98 minus N of A intersection B. They given both. Right. Both given. K% is the number of patients who has both. So it is K, common region. So now this value, we know that the value of P of A union B, lies between, this is U, right, 100, lies between, this is the maximum of P of A comma P of B. P of A comma P of B. So maximum of P of A comma P of B. What is the maximum of P of A comma P of B? 89. N of A is 89. N of B is 98. Right. Now, now I am using this 89, 98. So what is the maximum? 98. Less than or equal to P of A union B, less than or equal to, this is 100. Now what is we have P of A union B 89 plus 98 minus K. Right, as it is. So this is 89 plus 98 minus K less than or equal to 100. So here 98. Right. So we will get here the minimum value when you replace this. Right. So we will get 98. This is the K value. You have to remove this part first. 89 plus 98. 89 plus 98. You will get 98 cancel minus 89. You will get minus 89 minus K less than or equal to this one. This one is 189. You can see 98. This is 98, 89. This is equal to 17. This is equal to 18. 187. Right, 187. So 100 minus 187. Now this is 87 minus 89. So I am multiplying with minus. So you will get 87 less than or equal to K less than or equal to 89. So this is the value of K, range of K. Right. This answer is D, 87 to 89. 87 to 89. Right. I hope you understood all these questions. Okay. So thank you. I am welcoming Kishore sir. He will teach chemistry part.
So hello my dear friends, and now we are into the analysis of chemistry paper, and my name is Kishore and I'm a chemistry expert at Extramarks. And before we start with the chemistry analysis, I want you guys to like the video and share the video with your friends so that they also get to know how the paper was there for the exam. Okay, so right now we are into the analysis of chemistry. So as usual, there is no need of looking at the level of question. It is always easier. Chemistry is a subject where the paper is always easier, and this time the paper was again based on the NCERT syllabus. So I would say the NCERT syllabus based questions were some of them, the physical questions were formula based questions, and there were so many memory based questions too. Okay, and there were questions from organic chemistry which were based on the reaction mechanism, and there were some reactions based on named reactions and also some tests. So these are the reactions, these are the questions which are being asked in the chemistry part of shift 1. So let's see quickly what are the different questions that have come in the exam. Okay, and as usual, chemistry is something which is going to be a scoring subject. So as a science student, if I am writing the exam, I would definitely start with the chemistry part, which is quite easier for me. So whenever you start with chemistry subject, it is quite, because it is easier and scoring, you gain confidence. So this confidence can be carried to the next part, that is physics or mathematics. So I always advise my students to start with chemistry, which is easier to understand and answer and to score well, and which is going to make your overall score look good. Just like MS Dhoni playing the cricket, where everybody is getting out for single digits, there is one person who scores well and makes the overall score look good. So this is what the chemistry is, easier and a scoring subject. Okay, so let's begin with the questions. So as I have told you, the questions have come mostly from organic. So it is not, it is equally divided, all from physical, some of them from physical, some of them from organic, and also from inorganic. And most of them were theory based. So most of the questions which I have collected here are from the memory of the students which I have collected. So there might be some difference in the formation of the question, but the concept remains the same. So that is how we are going to start our session. So let's begin with the first question. The first question is about a Frankel defect. So this is a question from the first chapter of your 12th syllabus, that is solid state, and this is about the defect which they are talking about. So it is a statement kind of questions. So let's see what is this question about. So the question is about the Frankel defect, which the statement first says that Frankel defect, okay, Frankel defect shows interstitial as well as vacancy defect. So they are always, so JEE Mains always try to check your basic knowledge that is there from the NCERT. So they are trying to check the basic knowledge, whether you know Frankel defect, whether you know vacancy defect and interstitial defect, whether how can you relate them. So that is what they are going to check from the first statement and from the second statement. So let's go with the first statement. So Frankel defect, can we say that Frankel defect is similar to interstitial and vacancy? So let's have a quick look at what is Frankel and interstitial and vacancy defect. So if you talk about Frankel defect is, in an easier word, if you want to learn Frankel defect, it is a defect caused by dislocation. So that there is a dislocation of the ion. Usually the smaller ions which can be displaced. Okay, so the smaller ions which are there in the cation, so which are there in the ionic compound, where in ionic compound you will find the positive and negative ions repeating themselves, and you know that this cations being very smaller in size, there are chances of misplacement. So that is what causes the Frankel defect. So this cation, which is smaller in size, misplaces or displaces into the empty space present between the ions. So that is called as the Frankel defect, a dislocation defect. Okay, and what about your interstitial defect? Interstitial defect is nothing but, see, in the previous case Frankel defect is also the displacing of the ion into the interstitial space, but here it is its own ion in Frankel defect. It is the own ion of the ionic compound, but in the case of interstitial defect, it is the foreign atom or a foreign impurity. So impurity entering into the ionic compound and occupying the interstitial space. You can see an extra atom or an extra ion coming and occupying the interstitial site. So that is about an interstitial defect. Now what about your vacancy defect? Vacancy defect is completely creating a vacancy. So there is completely missing of a particle, missing of an atom, missing of an ion. So that is the difference between Frankel, which is dislocation. What is interstitial? Interstitial is an entry of foreign element, foreign atom into the ionic compound, and where it is into the interstitial site. And what about vacancy? Vacancy is all about missing of ions. So this first statement is not correct. Okay, and what about the second statement? In Frankel defect, the solids show color. So do they show color? So why do you say they show color? So usually the color you will see if you say that Frenkel defect is showing color, then what about the F centers that you have learned? So we have learned that F centers are the ones where the electron is trapped, and these electrons which are trapped into the site are responsible for the color of the compound. So it is not the Frenkel defect which is responsible for the color, it is the F centers which we have learnt in the defects, which is the reason for the Frenkel. So both the statements are wrong statements. Okay, so that is the first question which has come from the first chapter of solid state. Okay, so let's move on to the next one. So the next question is about, okay, the next question is from organic chemistry. As I have told you, the questions which have come from organic chemistry are, a few of them are direct questions, named reactions, or a identification reaction, a test reaction, or they are based on the reaction mechanism. So let's see what is this question about. They say that phenol is reacting with bromine in the presence of water. That is one case. Okay, and phenol reacting with bromine in the presence of CS2 as a solvent. So it is the reaction between phenol and bromine in two different solvents. One is the water and the other one is the non-polar solvent CS2. So remember that these two solvents are different. H2O is a polar solvent and CS2, carbon disulfide, is a non-polar solvent. So what do you expect here? So what are the A and B products that you are expecting? Will they be same or different? Okay, so let's see what happens when I add phenol to bromine in the presence of, in the solvent water. So this is what is happening. So whenever I add phenol to water in the presence of bromine, I see that there is tri-substitution of bromine. There is a tri-substitution of bromine, and usually this is a white precipitate too. This is a white precipitate. So this is a very special reaction of phenols which can be used as an identification test for phenols, which separates it from the rest of the alcohols. So phenol test, this is one of the very good example of the test of identification of phenol. So phenols added to bromine in water undergoes tri-substitution of bromine at ortho and para positions, forming 2,4,6 tribromophenol, which is a white precipitate. Okay, so this is the case of bromine in water. Now what happens if I add? So what is the reason why there is tri-substitution? We know that so we know that phenol, what about phenol? We know that phenol will undergo electrophilic substitution reaction. They undergo electrophilic substitution reactions, right? Aromatic hydrocarbons can undergo electrophilic substitution reaction. So, and we also learned that in electrophilic substitution reactions there are two types of products that you get. One is the meta-directing products and orthopara substituent. So when do we get this orthopara and when do we get this meta? It all depends upon the group which is present over here, over the benzene. And OH being a very good electron donating group. So this is a electron donating group, electron rich group. So whenever you have electron donating groups like OH attached to the benzene, what they do is they increase the electron density at ortho and para positions. They increase the electron density at ortho and para positions. Okay, so that is how you will see that the electrophile, which is incoming electrophile, will enter into the ortho and para positions, and usually the para product is more stable than ortho. Okay, but in this case where I am adding it to water, so I am adding this to water, there is something new happening. What is happening over here is, so phenol reacts, or you can say it dissolves in water. So it dissolves in water and it forms something called as phenoxide ion. It forms a phenoxide ion, O minus, okay, and it forms H3O plus. So this is the reaction. This is called as the dissolution of phenol into water. What phenol can decolorize water. That is what is happening. It is dissolving into water, forming these ions. So now if you look at this particular ion, this is called as the phenoxide ion, and if you observe carefully this one, O minus, the oxide ion here, it is highly electron dense group. Okay, so I am telling that already that electron donating groups will increase the electrophilic substitution. So this is so powerful that it is going to substitute all its positions. It means all the ortho para positions will be completely filled with the electrophiles. That is the reason why we will be seeing the tri substitution, not the mono substitution. or di substitution. Okay, it is the tri substitution which is happening because of the phenoxide ion which is formed whenever added to a polar solvent. So phenol added to a polar solvent makes it even more electron dense group, and hence you will see the electrophilic substitution to be very vigorous. Okay, and that is how you have the tri substitution happening, and you have all the ortho and para positions occupied by bromine. Okay, so that is the reason why you have tri substitution. Now coming to the CS2. So when you dissolve phenol into CS2, okay, so when you dissolve phenol into CS2 containing Br2 as a reagent, what is happening? Because phenol, as I have told you, it is a very good electron donating group, but not as good as the phenoxide ion. So that is why here also you will see the ortho para products here. So you will have one para product, and also you will have one ortho product. So this is a para product and this is the ortho product, and obviously we have seen that due to steric reasons para is the most stable one. So my A answer would be this one, and my B answer would be the para substituted phenol. So that is my answer for this question. So very important question. This you will find it in your NCERT book under the topic of phenols chemical reactions. Okay, right. So the next one, so this is what the reaction, what is the summary of this? So you get from phenol into the water, you get tri, and phenol into CS2 solvent. See, CS2 is a non-polar solvent. CS2 is a non-polar solvent, so it cannot ionize. So this CS2 being a non-polar solvent, it cannot ionize the phenol which is there, but water can ionize the phenol, forming a phenoxide ion. So that was the summary of this question. Okay. Next, the question is from hydrogen chapter, that is nothing but water. So this is a question related to water. That is nothing but there's a very important topic called as degree of hardness, or you have learned the different ways in which the hardness of the water can be removed. How do we convert the hard water into a soft water, which can be used for our daily activities? So how do we convert this? How do we remove the hardness? So by looking at the options, all the options are going to tell us about removal of ions. But the question is, tell me, which of the following process is used for deionizing the water? It means it is able to remove the cationic ions which are there and also the anionic form. So it is able to remove both the ions, the positive ions and the negative ions which are there in the water. So which among the following process are doing so? So let's see one by one. So if you look at Clark's process, okay, Clark's process is a very simple technique to remove the temporary hardness of water, and we just have to add the hard water to lime water with a little quantity of lime water, and we get the precipitate of a salt formed, and it is going to remove the cations, the Ca+2 ions and the magnesium ions which are responsible for hardness. So in this process, if you see, there is only removal of the positive ions, not the negative ions. Okay, let's go for the next one. It is Calgon process. In Calgon's process also, it is a technique used for removal of permanent hardness. Okay, so how it is used? We'll be using a molecule called as Calgon, which is again, the theme is again same. It is able to remove the positive ions alone. So here also the hardness has been removed. It means only the cations are being removed, not the negative ions. Okay, so here also we are removing the ions, we are deionizing it, but not in the form of negative and positive. Only the positive ions are being removed from the water. So to remove the hardness. Okay, so next one, the permitted process, nothing but the zeolite process. So in zeolite process, we pass the hard water through a zeolite molecular sieve, and how we get the pure water or the soft water from the bottom. So here also, if you see, it is again based on the same principle, exchange of ions. So here also, if you can see, it is the sodium ions which are being exchanged with the Ca+2 ions. So again, it is the same process of removal of cations. And now coming to the last one, I see the previous one is also called as the ion exchange method, but this is an ion exchange method which is very unique, because here we see there is removal of both the cations and the anions. The cations like Ca+2 ions, Mg+2 ions, and also the negative ions like sulfate ions, the chloride ions are being removed. So here we are seeing the removal of cations as well as the anions in the case of resin exchange. So here we are actually deionizing both the ions from the water. So my best answer would be the synthetic resins method for this question. So for deionizing the water, I have to use this process, synthetic resins process, where I am removing both the ions, both the harmful ions from my water. Okay, so that is my answer for this question. Let's move on to the next one. The next question is based on electronic configuration, okay? And it is a very commonly asked question in many of the exam, not only JEE Mains, it is also been asked in various examination. But there is a small twist in this question. So this is gadolinium, okay? So gadolinium, what is the gadolinium's atomic number is 64. So gadolinium's atomic number is 64. Now how do we write down its electronic configuration? So to write down the electronic configuration, we will use some basic techniques how to write down the electronic configuration. So how do we write down the electronic configuration? By using the nearest inert gas, okay? So if you see at the atomic number 64, the nearest inert gas which comes to my mind is xenon. And xenon, if you see, xenon is lying somewhere in the 5th period. It lies somewhere in the 5th period with an atomic number of 54. Okay, so I will start writing my electronic configuration. How? By writing xenon 54. Okay, so this is how I have started, 54. And how many electrons are left over to arrange them into orbitals? 10 more electrons. Okay, so now I should know what are the orbitals which are getting filled. So now see, this is the end of the 5th period, so I am getting into the 6th period. So you will find gadolinium somewhere in the 6th period. Okay, so in the 6th period, what are the orbitals which are getting filled? So the easier way to understand is, so in 6th period you will see 6s getting filled, 6p getting filled, 6s, 6p, and then you will have 5d that is getting filled, and 4f. So these are the orbitals which are getting filled in the 6th period. Okay, so now how many electrons are left over? Tell me. I have got 10 more electrons, so I can write down this as so I will write down first as 4f, then 5d and 6s. So in 6s I can accommodate 2 electrons, so 2 electrons gone. How many left over? 8. So 7 into this and 1 into this. So that is how I have written down my electronic configuration with my basic knowledge of my periodic table. Okay, so I have used the last element of the group, that is the noble gas configuration, and I have written down the electronic configuration of gadolinium. So mostly the question is been asked that how many F electrons are there in gadolinium. The answer is 7. But here the question is not regarding gadolinium, it is regarding GD plus 2. Okay, so what about GD plus 2? So what will be the case? What will be the electronic configuration? So it means I have to remove. So whenever we are removing the electrons, we always remove the electrons from the outermost shell. So it means I have to remove electrons from where? Not from 4f, not from 5d, from the outermost shell. And the outermost shell is what? That is 6s. So I am going to remove the electrons from 6s. So there are no electrons present in the 6s orbital. So the configuration reduces to xenon 54. Okay, xenon 54, 4f. 4f7, 4f7, and then 5d1. Okay, so this is what you will get as a electronic configuration of GD plus 2. And here again you will do a mistake because they are asking us the number of electrons present in the 4f orbital. So your answer, by looking at this, your answer must be 7. But 7 is the wrong answer. 7 is the wrong answer because there is a small concept involved in this, that is the contraction of the orbitals. So when you compare gadolinium with gadolinium plus 2, it means it has lost 2 electrons. So whenever for a cation, always the nuclear power is more, the effective nuclear charge is more. So what does the nucleus do in a cation? It will pull the electrons towards itself, right? So when the electrons are being pulled towards the nucleus, what is happening? Tell me. It is contraction which is happening. So you have to know a small concept called as contraction of the orbitals. So if you see the contraction of the orbitals, how many orbitals are there in this GD? It is 6s, then you have 5d, and you have 4f. So these are the orbitals which are there, and you have 7 electrons in 4f and you have 1 electron in 5d. So whenever there is a contraction by the nucleus because of the formation of the cation, where the positive charge is more dominating, the nucleus is more dominating, so you will see contraction more in the case of which, so you will see very less contraction in the case of s orbital, much more in the case of d orbital, and much more in the case of f orbital. The contraction, I am talking about the contractions here. Okay, the contraction of the orbital. So the contraction of the orbital is more in the case of f orbital. Okay, so the f orbitals are getting contracted more when compared to d and when compared to s. So, and one more thing you have to notice that there is a very little energy difference between the 5d orbital and 4f orbital. So this electron which is there, the unpaired electron which is there in the d orbital, will not be in the d orbital, will get transferred into the 4f orbital. Okay, but unpaired, being unpaired only, there will be no pairing happening. So apart from the 7 unpaired electrons you have, how many unpaired electrons are there? So they're asking us about the 4f electron. So now you will have how many electrons present in 4f. So this electron getting transferred into 4f orbital will generate how many electrons in the 4f orbital? So the answer will be 8. So the how many electrons are present in 4f orbital? That is what the question is. So the electrons present in 4f orbital is 8. It means one electron of the d orbital gets transferred into the 4f orbital because of less difference between their energies and because of the contraction. So because of the contraction, the electron drops from 5d orbital. 5d is over 4f. So this electron gets dropped from 5d orbital into 4f orbital because of the contraction and small gap between, a very less energy difference between the 4f orbital and the 5d orbital. So your answer is 8, not 7. So this is what the twist in this question. So most of you might have answered 7, but the answer is 8. Okay, if they would ask, in gadolinium how many 4f electrons are there, then my answer is 7. Then my answer is 7, not in gadolinium plus 2. In gadolinium plus 2, because of the contraction of the ion, these electrons, the electron in the 5d orbital get transferred into the 4f orbital because of the contraction and small energy gap. So that is the answer, 8. So the answer is 8 for this particular question. Okay, right. Okay, the next question is again from a chapter called as polymer, and as we know that always whenever you get a question from biomolecules and polymers, they are always straight from the NCERT syllabus. So this question is also a question which is from the NCERT lines, and you can see this reaction straight away in the page. You will find this on the top of the page with proper reactions. Okay, now what is this question about? So they're talking about Novolac. Okay, I hope you guys know what is Novolac. So they are asking us, when we react Novolac with formaldehyde, which of the following polymers are formed? Okay, so most of you know this answer. The answer is bakelite. So let's see how it is formed. Okay, so this is actually a condensation process. It's called as the phenol formaldehyde condensation, where I add phenol with a formaldehyde in the presence of little acid or a base, anything. So what will happen? A condensation reaction will happen. Later this condensation reaction will further convert into a polymerization reaction, a linear polymer. So a linear polymer will form, because you will see that there will be two isomers which are formed. That is, there are two products which are formed here, ortho isomer and a para isomer. So using those you will have a linear isomers formed, and this linear chain of this with a methyl group between, so this polymer is actually called as Novolac. Okay, so they are asking us the question about, when this Novolac is heated with formaldehyde again, with excess formaldehyde, what happens? So this reaction is actually stopping here. So if you add formaldehyde, if you take formaldehyde in excess, so when you take formaldehyde in excess and you are heating it, what happens? This linear polymer will furthermore polymerize into a 3D network like polymer, a solid. You will get a solid polymer, that is nothing but the bakelite. So this is your bakelite, which is a 3D network like polymer, and which is very, very hard, and this is also heat resistant and electric resistant. That is why you will see that the electrical switches which are made, there are made up of actually the bakelite. They are electrically resistant and also heat resistant too. So this is about your bakelite. This is there, this reaction is there exactly in your NCERT book. So that's nothing new. So they just asked a line from an NCERT book. Okay, so what happens when Novolac is added to formaldehyde? The answer is bakelite. Okay, right. So that was about a polymer question from organic chemistry. Now we are again getting into surface chemistry. So this is a question from surface chemistry from the topic adsorption. So what has been asked? So what is true for adsorption? So we are talking about adsorption from the chapter surface chemistry, and they're asking us, so this particular question can be solved if you know the thermodynamic activity which is happening during adsorption. Okay, so let's see what is happening thermodynamically. We know that adsorption means what? Tell me. There is gas getting adsorbed onto a solid surface. So they're asking about the adsorption of a gas on a solid. Okay, so let's see what is this adsorption of a gas on a solid and how are these thermodynamical factors changing. So basically they're asking us about delta H, the enthalpy of this adsorption, and the entropy involved in this adsorption. So basically, what is adsorption? So you can see that the gaseous particles which have a lot of energy with them, what is happening to the energy? So the high energy of the gaseous molecule, what is happening to the high energy of the gaseous molecule? They are getting adsorbed onto the surface. It means they are losing energy. So what I can say? So I can say that the delta H adsorption, will be what? Tell me. It will be a negative value. Why? Because it is an exothermic process. It is an exothermic process. Why it is an exothermic process? Because the gaseous particles are getting condensed over the surface. They are losing energy and they are settling down on the surface. So it is the adsorption of a gas on a solid or a liquid is an exothermic process which loses energy. So the delta H value will be negative, or we can say less than 0. So let's see the option where we have less than 0. So we have so many options with less than 0. So we have to also look at the delta S. What is this delta S adsorption? Entropy, change in entropy. So usually the easier way of understanding entropy is the randomness. We say the entropy is increasing if the randomness of the molecules increase. Okay, if the bonds are getting broken down, we say the randomness is increasing. Okay, so that is what's called as entropy is increasing. And what do we say entropy is decreasing? When the molecules are coming closer, new bonds are formed. When the interaction increases, we say the entropy is decreasing. So what is happening in the adsorption? You can see in this adsorption what is happening. The molecules, the gaseous molecules are losing energy, that is exothermic, and also coming closer and interacting with the surface. So they are forming new bonds with the surface. Okay, so what is happening in the adsorption? Adsorption is also less than 0. So this is also negative. So adsorption is also decreasing, and it is an exothermic process. So you can answer your question now. So delta H is less than 0 and the entropy is decreasing. So my answer is option number D. Okay, and I would give you one more important point. So this process, so how long will this process happen? So delta G is equal to delta H minus T delta S. Right? So what is happening over here is delta H values are what? Negative values, right? These are negative values, and delta S value is also negative. So there will be a situation where, see, overall this part is positive. So this is a positive value and this is a negative value. So there will be a situation where this delta H value will be exactly equal to minus T delta S, and that is a situation where the adsorption will reach to equilibrium. So delta G will become 0, or it will reach saturation. Okay, so the process of adsorption will slow down and it will go into equilibrium state. So that is about your adsorption, the thermodynamics of adsorption, a very simple concept, and it is there in your NCERT as it is with proper lines. Okay, so this is about the thermodynamics of adsorption from surface chemistry of 12th chemistry. Okay, so let's get into the next one. The next question is again from organic chemistry, and the question is between acetophenone. So there is a reaction between acetophenone. So it's very important for us to know the common names, or at least the IUPAC names of the molecules, because if you do not know the common names, the trivial names and the IUPAC names of the molecule, it's quite difficult for us to identify the molecule. If you're not able to identify the molecule, it's quite difficult for us to understand the reaction. So it's very important to know what is this acetophenone. So acetophenone, what is acetophenone? There is a phenyl group. So this is your acetophenone. So acetophenone. Okay, so acetophenone reacting with Br2 by KOH. So what comes to your mind by looking at this reaction Br2 by KOH? So I think it is something like haloform reaction, something like chloroform, bromoform, iodoform reaction. Yes, it is a reaction which is related to haloform reaction. Usually we get a question in terms of iodoform, I2 by NaOH, but this time they gave us in terms of bromoform. But the concept remains the same. What is the concept here? So haloform reactions, whenever we talk about haloform reactions, okay, so this is also a reaction which is called as a qualitative analysis. So we are actually identifying a molecule. So this is also a test, just like your test which we have seen, phenol reaction where the white precipitate has formed. This is also an identification test for which kind of molecules? Methyl ketones. So it is the methyl ketones which responds to this particular reaction. So this reaction is specific, haloform reaction is specific to methyl ketones, and this is nothing new. It is there in your NCERT book in the organic chemistry chapter called as aldehydes and ketones. Okay, so haloform reaction, methyl ketones will react. Basically it is an oxidation reaction. Okay, so this molecule will get oxidized into what? So this will get oxidized into CO minus. Okay, so you will be getting a O minus, plus you will be getting CHBr3 as a precipitate, which is quite yellowish in color. Okay, and this will have a very characteristic order of chloroform. How chloroform, bromoform and iodoform, they will always all have the similar kind of smell, that is the chloroform kind of smell. Okay, and the important part is you will get, this is a visual test. You see there are something called as visualization test, where you will see the confirmation of test with the help of some colors, formation of precipitates. These are called as visualization tests. So this is also a visualization test where I could see a formation of yellow precipitate, which confirms that yes, this reaction is a positive reaction. If the reaction is positive, it means what is that? So the sample which is given contains a methyl ketone. So in this case it is the acetophenone which is taken, which is performing this reaction. So what is that? Acetophenone converting into an oxide form, and the bromoform which is formed, which is in yellowish color and as a precipitate. So this is about your reaction. And the haloform reaction, as I have told you, a reaction to identify the methyl ketones. Next. Okay, this is a question which you have learnt in the chapter called as hydrocarbons of your 11th, and this is a reaction which is meant, which anybody can solve it. Okay, and everybody knows this reaction. What is that? Markovnikov solution, because you can see there is an alkene present, okay, diene with HBr. So we know that alkenes undergoes what kind of reaction? It is the electrophilic addition reactions. They undergo electrophilic addition reactions, and these electrophilic addition reactions are being understood with the example, with the help of Markovnikov solution. Okay, so we know what is Markovnikov solution. We know by the statement that the negative end will go to that carbon which is having lesser number of hydrogens. That is what we know about the Markovnikov solution. Okay, but if you do not know what is the mechanism through which the products are formed, you will go wrong in this particular question, because this question can be answered only if you know the mechanism. Okay, so let's see what is the mechanism. And in Markovnikov solution, it is the carbocation which is going to tell us about the major product. The more stable carbocation formed, the more is the product formed. The final product, the major product, depends upon the most stable carbocation, most stable intermediate, and the intermediate formed in this case is carbocation. So let's see how it is going to happen. You know that the first step is what? Tell me, addition of proton as H plus, right? So when this H plus attacks, so this H plus can attack this particular double bond, it can also attack this particular double bond. So what are the different possibilities in which you will get a carbocation? So let me write down all the possibilities of carbocation that are expected. So the first carbocation which I am expecting is 1, 2, 3, 4. Okay, so I am expecting a carbocation here. So this is one carbocation. So one more, 1, 2, 3, 4. Here, this is one more carbocation. Okay, it means this double bond. So either positive here, positive here. So that is what I have written. Or you will also get a carbocation. Okay. Okay, this time you will get a carbocation where? Here. So there is a possibility of getting a carbocation here, or you will get a carbocation here. So these are the 4 different possibilities you will be getting. Some of you might have gone through this one, some of you might have gone through this one and this one. But what is the correct sequence? What is the correct one is, you have to observe which is the most stable carbocation. What we have learnt in terms of carbocation stability, it is tertiary greater than secondary greater than primary. So based on that, if you see over here, so this is a primary carbocation. So I will just discard this thing. So this cannot be my answer. This is a tertiary carbocation. Okay, this is a tertiary carbocation. And what about this one? This is a secondary carbocation. Okay, and what about this one? This is a secondary carbocation. So if you see, there is a tie between, so this is a tertiary carbocation, but it is not in resonance. But here if you see, this is a secondary carbocation which is in a resonance. Okay, so what I can do? So most of your answers will be based on this one or based on this one. Okay, so between these two, what will be my answer? So if you look at this one, so this is the most stable one because this is tertiary, this is secondary, this is tertiary, which is more stable, plus there is something called as resonance. So there is resonance, there is a possibility of resonance in this particular thing. It means tertiary plus resonance. This is secondary plus resonance. So I will choose this one as my most stable one, or we can say allylic carbocations are even more stable. So this is tertiary plus allylic. So tertiary plus allylic will make this carbocation the most stable. Remaining all are not so stable as this one. Okay, so this is going to give me the answer. So I'm going to choose this particular carbocation, which is tertiary plus allylic. So 1, 2, 3, 4. Okay, then I have the double bond over here, and I have one methyl group with a plus sign. So this is what I have selected for formation of product. So this will give me the answer. There is one more possibility of rearrangement over here. So most of you might think that this is the final carbocation which will give me the answer. It means finally you will attack the Br minus over here and you will get an answer. So what is the answer you will be getting over here is, so this is what you will be getting. Okay, so but there is a small one more concept over here. So what is that? There is a possibility of resonance. Since it is an allylic carbocation, there is a chance of resonance. So this can resonate. So this can resonate, and you will get one more structure over here, that is this one. And your carbocation goes to this portion. Okay, so there is a resonance happening because it's an allylic carbocation. So whether this is your correct answer or this is your correct answer, what will be your correct answer? So I would say this is my correct answer. So this is the major product. Why? Because if you see between these two, so I have selected this one among the 4 carbocations. Now I am going to select one of them based on the resonance. So if you see this alkene and this alkene, we have learned that more substituted alkenes are even more stable. The alkenes which are more substituted. So if you see this alkene is more substituted when compared to this alkene. So I will choose this as more stable. So this carbocation with the allylic rearrangement is the most stable carbocation, and we get a major product out of this. So this will be your minor product. It means the next major, and this will be your major product. So my final answer is this one. Okay, so that is how most of you will confuse with the carbocation as well as with the rearrangement because of the allylic resonance. So this could be answered only if you know the basics of organic chemistry, that is the carbocation stability and the resonance thing, and also the reaction mechanism of Markovnikov's addition. So that seems to be very easier, but it is quite conceptual. So let's go for the next one now. So this is the question from inorganic chemistry, and this is a very simple question based on knowing how many lone pairs are there. So this could be answered very easily because you know how to know the lone pairs present over the central atom. So they are saying that there is an interhalogen molecule AB3. There is an interhalogen molecule AB3, and it is a T-shaped. It is a T-shaped. They are giving us hints. So always they try to give us hints using which we can answer it. So it is a T-shaped interhalogen compound, that is AB3 with an empirical formula AB3. We need to find out how many lone pairs are there present over the central atom. Okay. So let me select this AB3 molecule as ICl3. Okay, ICl3 is my molecule. So how do we know how many lone pairs are left? Anybody can answer this. Even a 9th or 10th student going student also can answer this. So how many lone pairs? We know that iodine has got how many valence electrons? 7 valence electrons. So iodine has got 7 valence electrons. It means what? Out of this 7 valence electrons, it will use, because chlorine is a it will form single bonds. So chlorine can form single bonds. So it will use 3 of the electrons for bonding with chlorine, right? 3 of the electrons for bonding with chlorine. So how many are left over? Out of the 7 electrons, 3 are being used up in forming bond. So how many are left over? Obviously, how many bonds are left over? How many electrons are left over? It is 4. So they are asking us about the lone pair. Lone pair means how many? Tell me. One pair means 2 electrons. So they are asking us about the lone pair electrons which are left over, and that is 2. So there are 2 lone pair electrons which are left over. And you can also verify with the data which is given. See, what is the hybridization of this particular molecule? Hybridization, how do you identify the hybridization? There are 3 sigma bonds. So these are my 3 sigma bonds. So 3 sigma bonds plus 2 lone pair. It means I need to have total 5 orbitals I need to have total 5 orbitals for this molecule, and this 5 orbitals tells us that it is sp3d2 hybridization. So it is a sp3d2 hybridization with 3 sigma and 2 lone pair. It means its geometry is something like, what is that? It is something like, you know, a trigonal bipyramidal, but it is a T shape. You can see over the T shape here. I'll show you the T shape over here. So this is your T shape. You can see the T shape over here. Okay, so sp3d2 hybridization with 5 orbitals, where 3 orbitals will have 3 sigma bonds and the 2 orbitals will contain the 2 lone pairs of the iodine atom. So the answer is 2 lone pair atoms. Okay, so that is my answer for this question. So it was a very easier question which could be answered within 10 seconds. Okay, let's move to the next one. Which among the following has a violet compound? Okay, so this is a memory based question. You don't have to know the concept, no numerical, nothing. It is completely a memory based question, and we know that among all these molecules, if you can remember, this is a blood red color. Okay, this is a molecule. You will find these molecules in organic chapter where you have done this qualitative analysis, where you find out, where you identify the organic molecule. So identification of carbon, hydrogen, sulfur, nitrogen, there you find all these molecules as, you know, the products. So this is a blood red color, and these are cyanides and cyanates. So these are usually brownish and bluish color. Okay, but there is one molecule, this is called as the nitroprusside. Okay, so sodium nitroprusside, which is violet in color. Okay, so that is my answer, and you will see this in this particular reaction where you use this lezine test and add it to this reagent. So when you add this lezine's extract to this sodium nitroprusside, you immediately get a bluish violet color. So this is a very sensitive reaction. Immediately you drop a if you add this drop of lezine's extract to this particular reagent, you will get an immediate bluish color, violet bluish color, which represents the formation of sodium thionitroprusside. So this is a memory based question which can be answered very quickly if you are very clear with your memory. Okay, so right. So the next question is from structure of atom. Then this is a question which this is a question which is there in your Bohr's models are also there in your 10th syllabus too. So let's see how we can answer this. So in Bohr's model, it has been seen. So this is a question based on velocity. Okay, you might have seen that in your NCERT they have discussed about the radius. Then now we are discussing about the velocity. Okay, so what is this velocity of electron and how it is dependent? So to talk about the velocity, we should know the formula. What is the formula which tells us about the velocity of electron in the nth orbit? This is the formula which tells us about the velocity of electron in the nth orbit. And if you see carefully, if you substitute all the constants, you are left with V, velocity of the electron in the nth orbit, velocity of electron in the nth orbit directly proportional to Z by N. So this is what is important to answer this, and you can see clearly that this Z is nothing but this Z tells us about the nuclear. It tells us about the nuclear pull, or how dominant is the nucleus. So this tells us about the nucleus, how dominant is the nucleus. It tells us about the nuclear pull, and this tells us about the principal quantum number. N is the principal quantum number. It means it tells us how far is the electron. So this tells us about the size of the atom. So principal quantum numbers usually tells us about the size. So what do we know about this? So the statements, if you see, they say that velocity of the electron increases. Velocity of the electron increases with decrease in the positive charge. Positive charge is nothing but the charge of the nucleus. Okay, nothing but they are talking about the nucleus. So what does that tell me? I think it is wrong. Why? Because if you see, they are directly related. Velocity of the electron is directly related to the positive charge in an atom, that is nothing but the nucleus. So it means the electron which is much nearer, more is the positive charge, more closer is the electron, more will be the speed. We have learned that the electrons which are more closer to the nucleus will have more energy, and they will be moving with high speed. So the electron much closer to the nucleus will move with very high speed, and the electron which is far from the nucleus will move with lesser speed. So that is the concept behind this. Okay, so to avoid falling into the nucleus, the electrons which are revolving will be moving with very high speed. So the electrons which are closer to the nucleus, or we can say more powerful is the nucleus, more closer will be the electron, and hence the electron will be moving with very high speed. And if the power is less, the electron will be farther and it will be moving with lesser speed. So now how do we relate electron with the size or the distance from the nucleus. So as the n value increases, it means as the electron is getting far from the nucleus, what happens? Its velocity is lesser. So let's look at the statement. Velocity decreases with an increase in the principal quantum number. So I agree with this statement. So statement 2 is correct, but I do not agree with the first statement, because the velocity will be more for that electron which is much closer to the nucleus, or where the nucleus is more powerful, the electron will be moving with very high velocity. Okay, so that is the concept behind this. So as I have told you, it's all about the formula and applying the concept. So completely conceptual. Right, so that was a question from structure of atom. So the next question is also from physical chemistry, and that too from states of matter, and it's a very easier question which is related to the RMS speed. So it is also a formula based question. So what is the formula we know? It is the URMS. The RMS speed, what is the formula we know? It is root over 3 RT by M. So this is the formula that we know, root over 3 RT by M. And they say they want to compare the RMS speeds of 3 different molecules, oxygen, CO2 and nitrogen, at a constant temperature. So temperature is kept constant. So if temperature is constant, then you can say it is URMS is inversely proportional to their M. What is this M here? It is a molecular weight or the molecular mass, molar mass. It is a molar mass of the gaseous particles. And you know that it means what? Tell me, heavier is the molecule, lesser will be the speed. It's a very general concept. Smaller the molecule, easily they can move, so their RMS speed will be high. So heavier is the molecule, their RMS speeds will be lesser. So let's look at their molecular weight. So N2, how many grams it is? 28 grams. CO2, that is 44 grams, and oxygen is 32 grams. So what do you say about their velocities? I would say that the lighter one will have the highest one. It means nitrogen will have the highest speed, okay, when compared to it will be oxygen, which will be the next highest, and the last one will be CO2, which is the heaviest of all. So this is the URMS in the case of these 3 molecules, nitrogen, oxygen and CO2. It is very simple concept. At constant temperature, the heavier one will have the lower speed and the lighter one will have the higher speed. That is, nitrogen being lighter among the 3 is having higher RMS speed. Okay, so that is a very easier question, I would say, from physical chemistry and from the chapter states of matter. Right. So the next one, the ratio of water of crystallization present in, so it is a numerical question, integer type question, and we need to know what is the formula of Morse, what is Morse salt, and we need to know what is potash alum. So if you do not remember the formulas, this answer cannot be done. It is completely memory based. Okay. So if I talk about Morse salt, okay, which is FeSO4 dot NH4 taken twice SO4 dot 6H2O. This is your Morse salt, and you have potash alum. Potash alum, it means it is an alum. So what about alum here? So talking about alums, let me take potash alum, okay, K2SO4 dot Al2 SO4 taken thrice 24H2O. So the question is very simple. If you know the formulas, you can do this within 10 seconds. But if you do not know, you will end up with the wrong answer if you guess it. So it's very simple. They are just asking us the ratio of water of crystallization. The ratio of water of crystallization of Morse salt present to that of potash. It means Morse salt by potash. It means 6H2O by 24. This is what they are asking us. And which is 1 by 4, nothing but 0.25. Okay, nothing but this could be written as 2.5 into 10 raised to minus 1. So this is my answer. So such an easy question. The only thing is that if you know the formula, it could be considered as an easy one. Otherwise, you end up with a wronger one by guessing it. So this is completely a memory based question from inorganic chapter. Okay, now we are getting into one more inorganic question, that is Ellingham diagram. So we should have this knowledge about Ellingham diagrams. Basically, where do we use this Ellingham diagrams? So this Ellingham diagrams which we are talking about, I'll give you just an idea about what is this Ellingham diagram. So usually Ellingham diagrams are a very useful technique to talk about what type of reducing agent can I select for my reduction of this metal oxides. So you know that after the process of calcination and roasting, the metal which you are trying to extract are in the form of oxides. So now to get the metal out of this oxides, I need to reduce them. So to reduce this metal oxide to metal, I have to use a reducing agent. Okay, I have to use a reducing agent keeping in mind the temperature factor. It means I should see this metal oxides which are there. If I heat it to very high temperatures, they will automatically get broken down into metal, but not for all. So it means I have to also consider what reducing agent I have to select. I have to be very specific with the reducing agent, because we are talking about metallurgical process, which is nothing but extracting the metal with the lesser expenditure. Okay, it means I have to select a reducing agent which is very cheaper and which is very easily available. And second thing is that I have to take care about the temperature that is maintained. At lower temperatures, if I am able to use a reducing agent which is very easily available, that particular process of reduction will be the best process for that particular extraction. So this Ellingham diagrams are going to give us an idea about what kind of reducing agents can I use for the reduction of the metal oxides to get a metal at what temperatures. Okay, so this is that curves that you get to see. These are called as the Ellingham diagrams. And one important use of this is that, see, this is the graphs which are drawn between the delta GF of oxides, versus the temperature. So at what temperature can I extract the metal out of the metal oxide? So if you see, there are many lines over here. So there is a very simple concept that you can use over here, is that, so the metal line which is below, so the metals which are below can be used as a reducing agent for the metal oxide above. For example, if you see over here, I can use calcium as a reducing agent for reducing the oxide Al2O3. So to get aluminium out of this oxide Al2O3, I can use calcium, because this line lies below this. So that is the logic behind these lines. Okay, so the lines which are below can be used as a reducing agent for the line which is above, for the metal oxide line which is above. And you also get to know at what temperature should I use. So this is the basic concept of Ellingham diagrams, that it is used to select the reducing agents based on the temperatures too. Okay, so Ellingham diagram is used to check so we can say that it is used to identify the reducing agents which can be used in a metallurgical process to reduce the oxides into their metal. And Ellingham diagram, as we move from left to right, okay, the delta S increases. Okay, this point, if you can see over here, see, this is delta G, right? So delta G is equal to delta H minus T delta S. Okay, so, and you can see that most of the lines are going upward except few lines like carbon monoxide. Okay, so why they are going positive slope? Positive slope represents that the delta S values are decreasing. So this delta S value is decreasing, and hence this entire value is positive. So this is a graph with positive curves. So this equation tells us that positive curves means the curves which are going upward tells us that they have the positive slope. Positive slope means nothing but the delta S values are decreasing. So that is the answer for the second statement. So we move from left to right, the delta S values are decreasing. So that is the answer for your second statement. Okay, so it means when we move from left to right, the delta S values are decreasing, not increasing, to keep the slope upward. And you will see few of them going down, and just like carbon monoxide. So this carbon monoxide whose lines goes down is a best reducing agent, can be used at any temperature too. Okay, let's move on to the next one now. So there is a question based on titrations now. Okay, so let's see, this is a question which can be asked from redox chapter or from electrochemistry chapter 2. So this is a question which is based on redox, which is completely a practical knowledge again. So this is a question based on the indicators. So methyl orange, usually methyl orange, the indication range is what, tell me? It works well between the pH range of 3 to 5. Specifically approximately 3 to 5. So between 3 to 5, if the end point is between, when you are doing a titration and the end point is between 3 to 5, you can use methyl orange. Or you can say whenever you add a stronger acid, whenever you have strong acid plus a weak base, titrations, you can take methyl orange as a indicator. And what about phenolphthalein? Phenolphthalein is something like a basic indicator. Its range is between 8 to 10. Its range is between 8 to 10. It means pH range between 8 to 10. If your equivalence point lies between this 8 to 10, then this would be a better indicator. So basically it is used for strong base. Whenever you're titrating a strong base with a weaker acid. Okay, so that is what the concept here. And I can also show you the graphs. How do you use the graphs? So for a strong acid, whenever you are titrating strong acid with a weak base, the graph would be something like, so this is the pH versus, so always we add a stronger component to a weaker component. So this time I'm adding a stronger acid to the weaker base, and the curve that you will be getting is something like this. So it will be something like this. Okay, so this is something what you will be getting for a strong acid plus a weak base, and for a weak acid, it means strong base plus a weak acid. How will you get a graph? Okay, so it will be something like this. So it means you here can use the lower range. So this is the range where you can use the weaker acid as a indicator, and here we use the stronger component as a indicator. So that is why we can use phenolphthalein whenever you do stronger base versus a weak acid, and methyl orange indicator, which is usually used in the case of stronger acid versus the weaker base. So depending upon the ranges of their individual indicators, we can select the indicators on the type of titrations that we are doing. Okay, the last might be the last question of the session. So out of the given properties, which among, so this is an integer type question, so we have to select among which they have given us 1, 2, 3 and 4. So they have given us 4 properties, and which among them on which the reduction potential is dependent. So they are asking us on which among the following properties your E naught value is dependent. Okay, so to answer this, first we have to know how do we calculate this E naught. So E naught, so the first formula which comes to my mind is delta G naught is equal to minus NF E naught cell, right? So to find out the reduction potentials, I need to find out the delta G naught, right? And how do you find out delta G naught? Delta G naught of a process can be calculated very easily. So let me take this process, let's say reduction of a metal M, which is solid, converting into M plus X electrons, okay? So this is the reduction process, and I need to find out the E naught. And how do you find out the E naught? By using this formula. Delta G naught is equal to minus NF E naught. And how do you find delta G naught now? So to find out delta G naught, it is a sum of all the process which is happening during the conversation, okay? So here if you see here, this solid has to be first converted into a gaseous atom, nothing but sublimation. So you will be getting delta G sublimation. Okay, so you have to take the help of delta G sublimation. It means I need the help of sublimation. Where is sublimation enthalpy? Here. So I need to take the help of sublimation. Then this metal has to, what it has to do? It has to ionize now. So when it has to ionize, I have to use delta G. So I have to use delta G ionization enthalpy. So it has to ionize into ions. Okay, it means it has to convert into its ions like this. Okay, it means I have to again use the ionization enthalpy. It means this one. So I have used 2. Let's see whether I can use hydration enthalpy. Yes, because I have to add this to water, right? I have to add this to water. So by adding it to water, nothing but I will be using the hydration enthalpy. So I am going to use the sublimation, ionization and hydration enthalpies to find out the delta G net, and from here I will be able to find out the E naught. So what I can say, so this E naught, the reduction potential which I am calculating, is indirectly dependent on these 3 properties, that is ionization enthalpy, the sublimation energy and the hydration energy, but not the electron gain enthalpy, because you don't see any gaining of electrons in this process. It is all sublimation, losing the electron and hydrating itself. Okay, so it is 3. So my answer will be 3. So 3 among these 4 options is my correct answer. Okay, so apart from this, we also got some simple questions, like there was one more question, like there is isobutane. So isobutane is given. So isobutane reacting with Br2 in the presence of sunlight. So what is the answer you will be getting? So we know that this is a reaction from hydrocarbon chapter, that is halogenation, where this halogenation depends upon the type of free radical which is formed. So what is the free radical which are possible from here? The free radicals which are possible from here are, this is one free radical which is possible, and the other free radical is this one. Right? So I have two free radicals which are forming from isobutane, and which is more stable? We know that tertiary free radicals are more stable than the secondary free radicals, than the primary free radicals. So based on this, this is going to give me the major product. So this is going to give me the major product, like, so Br is going to attach to the tertiary carbon. So this is my major product. Okay. Apart from this, you also had some questions from mole concept. So there was a question from mole concept where you have to, where they have given you the molality. So they gave you the molality information. Okay, they gave you the molality information. They also gave you the information about density of the solution, and they're asking us about the molarity of the solution. So here also you can find out the molarity of the solution. To find out the molarity of the solution, what do you need? It is the number of moles of solute that you need and the volume of solution. Okay, so this is what I need to find out the molarity. So number of moles, yeah, number of moles is also given. So number of moles is given, molality is given, and density of the solution is given. So I just have to find out volume of the solution from using this two information. So I'm going to use the volume of the solution and then substitute in this formula. Okay, you also have some ready-made formulas, but I do not believe in remembering the formulas. You should always be able to derive the formula, and or you can do this conceptually. So there was a question from mole concept, and you will always expect, you can always expect a question from mole concept as well as from stoichiochemistry, chemistry from in your JEE Mains examination. Okay, so apart from this, there are many questions which were completely formula based, and also you can say they were memory based, and from organic chemistry they were completely reaction mechanism oriented. So this was all about the chemistry analysis what we have done so far, and I hope you guys were you have understood all the questions clearly, and I'm sure you guys have gained some confidence in if there are some students who are going to write down the exams in the next sessions. So as I always say, chemistry will be easier, so be confident. Just revise all the formulas, just revise all the named reactions from organic chemistry, and inorganic is all completely based on the memory of your like how much you can retain. So it's all about the formulas that you know, the concept that you have learned in organic chemistry, and the memory of your inorganic is going to give you very good marks in chemistry, and this is going to make the overall score look good. Okay, so that's it from the chemistry part, and now you all guys are desperately waiting for your physics analysis, and like you, our physics sir is also waiting to discuss all the physics question which have come in JEE analysis. So let's welcome physics faculty.
Hello students, welcome to Extramarks. So my name is Gautam. So let us discuss the physics analysis. So today the paper was quite easy, can say easy to moderate. So that is the feedback that we got from our students, and they also said that the class 12th portion, it was slightly more than the class 11th portions. Now if you have completed, that is the questions, right? The questions they asked, right? So they made sure that they have covered almost all the topics, almost all the chapters from 11th and 12th, and like I said, 12th standard syllabus, right? So it was slightly more than the 11th standard syllabus. Now let us take a look at few questions here, right? fine. So, all right. Okay, so my bad. So while copying, there was a mistake with this alignment here. So the question says, magnitude of vector OA, OB and OC are same, and you need to find the angle made by this vector OA plus OB minus OC with respect to, let us write it as with respect to. All right, so this is with respect to x-axis. All right. Okay. Now the diagram, it looks like this. So let me come here. I'll be drawing this diagram again. So vector A, it's making 30 degrees with the x-axis. Vector B, it's making negative 60 degrees. And vector C, it's making 45 degrees with the negative x-axis, right? Now I need to get the angle made by this vector OA plus OB minus OC with respect to x-axis, right? Okay, now let me sketch the diagram here. So I have this diagram like this. So this is x-axis and y-axis. Now I have vector A, which makes an angle of OA, let me say. It is vector A. Okay, so yes. So let me take it as just A. Let me call the number and letter, the vector, let me take it as OA. Then it makes an angle of 30 degrees. Now you have vector OB, right? It makes an angle of 60 degrees, right? Again, I wrote that vector symbol. Okay, fine. All right, so finally, I have vector OC, which makes an angle of, yes, so this makes an angle of 45 degrees. Sorry about that. Yes, 45 degrees. Now I need to get the resultant here, OA plus OC, OA plus OB minus OC, right? Okay, now what I'm going to do is I'm going to resolve the vectors, right? So let us resolve it into x and y components, right? Finally, we'll be getting the resultant vector. So you know the angle made by the vector, resultant vector with respect to x-axis, right? So you can write it as tan theta is equal to, finally, that is the resultant vector, right? So let me take it as the y component of the resultant vector and the x component of the resultant vector. So the resultant vector is this actually. Now let me resolve that, right? Okay, so A, right? So if I resolve it, so I'm getting something like this. Now I have A, yes, or otherwise let me write it like this. So A cos 30, right? A cos 30 I cap. So let me take the magnitude as A. So they have given the magnitude is A for all of them. So A cos 30 I cap, then A sin 30 J cap. It is easier this way, right? There won't be any confusion. If you are good enough, you can resolve the vectors, all of them, and you should make sure that they have asked for minus OC, right? So OC, it is already here. Then you have to take negative of OC this way. Then you can analyze and you can add it. It will be easy. Now, A cos 30 I cap plus A sin 30 J cap. I have resolved A. Next, let me resolve B now. So now I have magnitude is A again. So magnitude of all the vectors, I'm taking it as A, simply A, right? So A cos 60 I cap, right? Then this is minus A sin 60 J cap. So this is what you get after resolving vector B, right? Now if I resolve vector C, right? So here I have added, right? So OA plus OB, right? Plus OB, then minus of OC, right? So minus vector OC. So I'll take this negative sign here. I'll put a bracket. Then I have C, magnitude is A. Then I'll write A cos 45 I cap. Now this is towards the negative x-axis, right? So let me take the negative sign here. Then I have A sin 45 J cap. So that is in the positive y direction. So now I have A sin 45 J cap. So this is what I get. Now look at the J components, add them, right? And look at the I components, that is Y components will add and X components will add, right? So finally after taking the ratio, right? So the answer that you're supposed to get is, yes, if you look at the X components, right? So all of them are positive, right? So from this option, so from these options, option C is the correct answer, all right? So let us go to the next question. All right, again a misalignment here. So let me come this way. So here you need to say what is the resultant, that is this circuit, right? This combination, how it behaves. That is what you need to see here. All right, now you have vector A, sorry, this connection A, right? So they have shorted these terminals of this NAND gate, right? And the second NAND gate, its terminals are also shorted. Now you are connecting this input A to this shorted terminals, input terminals, right? Now you know that when you short the two terminals of a universal gate, that is NAND or NOR, right? So it will behave as a NOT gate, right? So finally I'm getting A bar here, right? And here I'm getting B bar, right? Now what you are doing is you are giving this A bar and B bar to, there is no connection here, you are giving it to a AND gate, right? Okay, now you have the final result. What you are getting here is A bar dot B bar, right? So A bar dot B bar. Now by De Morgan's theorem, right, you can clearly write it as A plus B whole bar. That is all. So this combination, right, this combination, it behaves as a NOR gate. So option A is right, right? So if you are confused, right, if you are confused and you cannot recall what is De Morgan's law under pressure, right, now you can form a truth table here. It will be easy. So you can say A, B and Y. So 4 inputs are going to come. So you can start putting it here, right? So A, B. Now you need A bar dot B bar. That is the output you need, correct? So put the values 0, 0, 0, 1, 1, 0 and 1, 1. So eventually you'll end up getting 1, 0, 0, 0. So this is the NOR gate, right? Okay, so let us go to the next question. It says at same temperature, RMS speed of hydrogen, oxygen and carbon dioxide, let it be VH2, VO2 and VCO2, right? Now the options are like this. So you have to compare the, or you have to arrange as shown here. You have to arrange the, okay, so the option C is same. Let us take it as greater than here. Okay, now you have to arrange them in increasing order or decreasing order or as per this option C here, right? Now we know that the RMS velocity, right, it is given as root 3, that is Boltzmann's constant kBt divided by m, right? So from this you can clearly see that the RMS velocity is inversely proportional to m, right, root m you can say, right? So if you look at the mass, right, so mass of hydrogen is less compared to oxygen and mass of oxygen is less compared to CO2, right? So lesser is the mass, more is the RMS speed. So option A is the right answer. Simple question. Okay, right. So let us go to the next one. All right. Find the power in the entire circuit when internal resistance is 0.6 ohms. All right. So again, there's a misalignment here. Sorry about that. Now I have this internal resistance here, which is 0.6 ohm, right? Now let me try to draw the equivalent circuit here. Here you need to find the power in the entire circuit. All right. Okay. Now, power can be obtained in two ways, right? How is that? You can do I square R, otherwise V square by R, right? So let us see which is suitable here. Now first and foremost, I have to get the equivalent resistance here, right? Now 4 and 4, if you observe here, there's a jump, right? So 4 and 8, they are in parallel. Okay, now 4 plus 8, I have 12, 2 and 4, I have 6, right? Okay, now looking at this diagram here, so 4 and 8, 4, 8, then 12 and 6, all of them are in parallel, all right? So now I have 4, then 8, then I have 12 and then I have 6. All of them are in parallel. Now this is connected to a battery, right? So which is whose potential difference is 2.2 volts and you have an internal resistance of 0.6 ohms. That's all. All right. Now let us try to get the equivalent resistance. And finally, since you know the potential difference here, right? So finally we can use that V square by R, right? So let me get the equivalent resistance across the battery now, right? So let me get the combination, let me get the equivalent resistance of this parallel combination where you have 4 resistors in parallel. Then I'll add it with 0.6 ohm, right? So finally we'll get that 2.2, all right? Okay. So 4, 8, 12 and 6, right? So they are in parallel. So 4, 8, then 12 and 6, right? Now the LCM turns out to be 24, right? So 1 by, so this is for the parallel combination. Let me take equivalent EQ, right? So 24, right? Now I have 6 plus 3 plus 2 plus 4, right? So this I'm getting it as 9 plus 2, yeah, so 15 by 24, right? 15 by 24. So therefore R equivalent, right? So it is actually 24 by 15, right? So 24 by 15, then you have plus this 0.6, right? So plus 0.6. Now I can simplify this, right? So 3 5 times, then 3 8 times. Okay, so 3 5 times and 8 times. So finally the equivalent resistance, right? So you are going to get it as 2.2 ohms, that is including the internal resistance, that is the potential the equivalent resistance across the battery. I should not say like that, because internal resistance is a part of the battery, right? Okay, let me say, considering the internal resistance, the total resistance is 2.2 ohms, right? So finally the power dissipated, right, in the circuit, it is given as V square by R. Now V itself is V is again 2.2 volts, right? So 2.2 square divided by 2.2 I'm getting. So the values are chosen so that you'll be getting the answer easily, right? So the answer, it is 2.2. Yeah, so yes, 11 by 5. 11 by 5 is the correct answer, right? Okay. Next, nice. So the fifth question, it says the initial mass of rocket is 1000 kg if it is accelerating upwards with an acceleration of 20 meter per second square. Find the rate of consumption of fuel if velocity of gases with respect to rocket is 500 meter per second. Now this is a variable mass system, right? So we know, all of us know that rocket, it works on the Newton's third law, right? It works on the principle of Newton's third law, right? And here the mass, right? So yeah, so coming to Newton's second law, right? We need to find the force now. Sorry, what is that? Yeah, so velocity, that is the consumption, right? So how much fuel is consumed per that is rate, so per second or per minute. So here it is per second actually. All right, okay. Now, so coming to force, right, we have two expressions. So this is when mass is constant, correct? This is when mass is constant. Now when velocity of the gases with respect to the rocket, right? So in such cases, we'll write V dm divided by dt. So in this case, this equation is applicable, right? Now let us try to sketch a rough diagram here. So this is the rocket and these are the exhaust gases with respect to the rocket. So velocity of gases with respect to rocket, VGR, gas with respect to rocket, I have written. So they have given it as 500 meter per second, right? 500 meter per second. Then they also say that the rocket is accelerating upwards with an acceleration of 20 meter per second square, right? And so this is the acceleration. So this is the as soon as you see this gases ejecting the rocket with some velocity, right, force is acting on the rocket. So that force itself is given by this, right? Okay, now you have this force, so let me call it as thrust. Okay, so Ft. Then you also see the gravitational force which is acting downwards. Okay, so however, the net force is the one which is giving rise to the acceleration, which is 20 meter per second square, right? So mass of the rocket, right? So that is 1000 kg. So at that moment you need to find the what is that? Yeah. So the rate of consumption of fuel, right? So 1000. Just a second. Sorry. Yeah. So here. Yes. So I need to take F net, right? So F net, let me take it as M into, or yes, now the forces, right? So the forces acting are the thrust force, right? So it is acting upwards, and yeah, so I can take it like this. F net is equal to MA. So at that moment, the mass of the rocket is 1000, right? Okay, now what is the net force? So thrust force is acting upwards and gravitational force is acting downwards, right? So let me write that, it is easy. So Ft, right? So Ft minus mg, right? So that will be equal to Ma, that's all, right? Okay, now Ft, right? So Ft, I can write it as V dm by dt. Let me write that here. So V dm divided by dt, right? Okay, so that will be equal to mg plus ma. So finally, dm by dt, I am getting it as mg plus ma, mg plus ma, right? Whole thing divided by the velocity, right? So velocity, that is here, this v here, in this case, it means the velocity of the gases with respect to the rocket, the same velocity, right? So vgr, let me substitute here, okay? Now you have 1000, you can take it common. So 1000 into g is 10. Let me take 10 because it helps here. So 1000 into 10 into 30, right? 1000 and 30, yeah. So 1000 into 30. Okay, now the whole thing divided by, now you have 500. So you got the answer. So 500, so you'll get cancelled here. Now finally you have 60, right? So 2 into 30, you are getting it as 60 kg per second. So everything is in SI units. So the answer, right? So it is actually 60 kg per second. In 1 second, 60 kgs of fuel is burning and it is ejecting in the form of the exhaust gases, all right? Okay, let us go to the next one. So it says, in an LR circuit, a steady state, right? At steady state, the energy stored in the inductor is 64 joules and power consumed by the circuit is 640 watts, all right? Find the time constant for this LR circuit, all right? So you have closed the circuit. They have set steady state. Now, as you can observe here, you have a DC source, right? Now, what happens at t is equal to 0? So the inductor will oppose slightly, right? Now, in steady state, the current, right? The current will become normal. So you know it will be taken at infinity. Nevertheless, so for steady state, this inductor, right? It behaves as a short circuit, right? So here we have to consider pure inductor, right? It is not dissipating any power, all right? Okay, so but in reality, you don't get to see any pure inductor. Yeah, now coming back to this, so the power dissipated in the circuit means it is only due to the resistor, right? So they have given it as 640 watts, right? And the energy stored in the inductor is 64 joules, right? Now as you can notice here, there is a steady current which is flowing in this circuit. The same current flows through same current flows through R as well as this inductor L, all right? Okay, now they have given the energy stored in the inductor is 64 joules and power dissipated in the circuit means resistor in this case, which is 640 watts. Now they want you to find the time constant, all right? Now time constant for RL circuit, right? It is given by L by R, right? It is given by L by R. Now we don't know L and we don't know R. So from this information, we need to find the ratio of, that is, we need to get the value of L and R, that is inductance and resistance, right? So let us try to get that. Now the information that they have given us, energy stored in the inductor is 64 joules, right? So you can say that energy stored in the inductor is half Li square, right? So which is actually 64. Okay, now let me try to get L here. So L I can write it as 128 by I square, right? 128 divided by I square, right? Now the power dissipated in the resistor, right? So it is given as I square R. Same current, right? Same current I is flowing through R and L here, right? So power dissipated I can write it as I square R, right? Now power dissipated also they have given, that is 640 watts, right? Yeah, 640 watts, right? Now I need to get the R here, right? So R is equal to 640 divided by I square. So I have an expression for R and this L, right, in terms of I square. So let me substitute it here, that's all. So you have 128 by I square divided by 640 by I square, right? So finally I'll be getting 128 by 640, which turns out to be 1 by 5, right? So this value turns out to be 1 by 5, which is 0.2 seconds, okay? So the correct answer is 0.2 seconds. That is the answer. Now let us go to the next question. Yes, interesting question. So it says charge Q is given to a spherical conductor of radius R surrounded by a concentric conducting shell of inner radius A and outer radius B, right? Now corresponding electric field diagram will be, right? Now this is the spherical conductor, the orange one, whatever you are seeing, right? Now for that we are giving a charge Q. So take it as a positive charge here. Yeah, it says positive charge. You can clearly see in the option itself it is printed as positive charge, right? Now surrounding that, right? So you can see it is exactly kept. So the shell, right? So you are enclosing it in a shell so that the sphere, right? The smaller sphere which is holding the charge Q, it is exactly at the center, all right? Now corresponding electric field diagram will be, so you need to identify the electric field diagram, right? Now whenever we study about this electric field in a conductor, blindly will be saying that okay, electric field inside a conductor is 0, electric field inside a conducting shell or a solid conductor, spherical conductor will be 0. It is not always, right? So only when you don't have any charge inside the spherical shell, in that case electric field will be 0, right? So no matter what charge you keep outside, right? So if the charge is outside, so charge induction will take place such that electric field inside a conductor or a spherical shell, anything which has cavity, any conductor which has cavity, electric field in that cavity and inside the conductor also will become 0. This property we will use it for for electrostatic shielding. But here you have kept a charge inside the spherical shell, right? So both are metallic, both are conducting only, right? Now what happens here is that this is the sphere which holds charge Q, correct? So charge is distributed uniformly. Now here you have that spherical shell, right? Here you have that spherical shell, right? Now this is neutral. They did not mention anything about that spherical shell, right? So charge induction will take place. So negative charges will come here, okay? And as you can observe from the diagram, the thickness, right? See, they have given the inner radius A as A and outer radius as B. So it is quite thick actually. Okay, it is quite thick. So this is the inner radius A and this is the outer radius B, right? Now negative charges will be induced in the inner surface and positive charges will be induced on the outer surface. Okay, so now you know that this region, whatever you are seeing, this is the metallic region, right? So this contains metallic atoms. Say this is made of copper or iron or something, right? So this is the region where you have this metal atoms, right? Okay, so here you will see that electric field is 0 because inside the metal, right? Solid. This is a solid metal, you can see, right? So there is some thickness, finite thickness there, right? So inside that electric field will be 0. Now due to this induction, you will start seeing electric fields like this, right? So the electric field lines, they will be like this. So these are the electric field lines, right? And you don't get to see electric field that is inside the boundary, that is between A and B, right? So between the inner radius and the outer radius, that metallic portion, you don't get to see any electric field. Now finally, since you have these charges here, these are induced charges only, right? Again, the electric field will continue here like this, okay? So finally, the correct option is you have electric field inside and outside except the portion where you have this metallic atoms present, okay? So the correct option would be option D. Right, it would be the option D. All right, okay, so let us go to the next one. So it says in a standard Young's double slit experiment, distance between slits is D and distance between screen and the slit plane is capital D. The location of the first maxima for red light is at y1 distance from the central maxima, and for violet light is at y2 distance from the central maxima again. So the reference is central maxima, right? Here they have given first maxima, right? So first maxima for both of them. All right, keep that thing in mind. Next, you need to find the difference between the wavelengths of red and violet lights. Now, as per the options that they have given here, okay? Right, now we know that the distance, right, fringe width, right? So the distance of the bands, it is expressed how many fringe widths, right? So in terms of fringe widths only we'll say. So y1, right? So let me take it for red light, okay? So y1, I'll write it as n lambda d divided by d, right? So fringe width times the number of that is the the fringe, the nth fringe from the central maxima will say, right? So they have given n as 1, right? Okay, so y1 I'll write it as, let me call lambda 1 as the wavelength of the red light. So y1 is equal to lambda 1 d divided by d. So lambda 1 is equal to yd divided by capital D. So y1d divided by capital D, right? Now same way here also they are talking about violet light, right? So violet light, the distance is, they have given it as, yes, y2, okay? So doing the same thing. So for violet you are going to get lambda 2 is equal to y2 small d divided by capital D, okay? Now they're asking you the difference between the wavelengths, right? So just subtract them, right? So if you subtract them, you are going to get small d divided by capital D outside, okay? Then you have y1 minus y2, that's all, okay? So this is the answer. So yeah, the correct answer is option C, all right? Let us go to the next one. Right, it says inside a spherical shell, which option is incorrect? All right, so if you look at the options, you need to understand they're talking about gravitation. This question is from gravitation chapter. All right, so it says gravitational field is 0. Then B, it says gravitational potential is 0. Then option C, it says gravitational field is same everywhere. They're talking inside. Okay, so inside, right? So everywhere inside, right? So option D, it says gravitational potential is same everywhere. Okay, so usually you will be many of us, right? So when I know many students, right, as soon as they see that option 0, right, so they will try to mark that. Don't do that. So first try to understand the problem properly, okay? Right, so here that we are talking about the gravitational field, right? So gravitational field intensity and gravitational potential, right? Now coming to this hollow sphere, right? That's been given spherical shell or hollow sphere, right? Now, gravitational potential, right, at a point is defined as the work done in bringing a unit mass from infinity to that particular point, right? Now, the reason is quite simple. Now, if you talk about the gravitational potential, any point on the outside and up to surface, right? So you can consider the center of mass of this spherical shell and you can derive it and you can get the expression. So from the center to any point outside, right? That is from the outside up to the surface, right? So this expression will hold good, minus gm divided by small r. Now if the point is here, you will replace this small r with capital R. That's all. Okay. Now once you enter, now I'll ask you what is the gravitational potential inside, right? So what we'll do is you'll bring it from infinity to the surface. Now from the surface to the inside point, right? If you want to bring that unit mass by basic definition, right? You need not do any extra work. That unit mass can move from the surface to any inside point on its own. That is, without the application of any force, this unit mass can get inside the unit mass is able to move anywhere inside. Why is that? Because when you keep any point mass inside, right, that is inside this spherical shell, it experiences force due to all the portions, right, all the portions of the spherical shell, such that the net force acting on it will become 0. Okay, so since the net force acting on this mass, any mass, unit mass you are bringing, that is how we define potential, right? So up to the surface, you have this potential given by this expression, right? Now once you are inside, right, so you need not do any extra work. So whatever the work you did from infinity to this point, do you think it will vanish somewhere? No. So that potential, whatever the potential you have at the surface, that is the potential inside also, right? Okay, I told you, because inside you don't have any net force acting on any point mass when it is kept inside the spherical shell. All right, so therefore you have to say the incorrect option. Gravitational field is 0. This is correct, right? So gravitational field is 0. Now gravitational potential is 0. No, because like I said, so if you remember the graph, right, so few of you can remember the graph, right? So sometimes we'll write like this. Otherwise, if you consider the magnitude, right, so we'll use the negative axis also. So this is the potential. So the graph, it looks like this, right? So the graph it looks like this. So whatever the potential you have at the surface, so this is for this point corresponds to the radius of the shell, right? The same potential you have it inside also, any point inside. Okay, so gravitational potential is 0, they're saying, and they're asking which is incorrect. So obviously option B is incorrect. Let us look at C and D also, right? Gravitational field is same everywhere. True. So gravitational field is 0 and inside it is 0 everywhere. So C, it holds good with A, right? Now look at D. Gravitational potential is same everywhere. That is, if you take any point inside, the gravitational potential is same. So A, C and D, they are correct. B is wrong. Okay, so that is incorrect, right? Okay, now in the 10th question, it says, in a LCR circuit, find the capacitance if the power dissipated is maximum given XL. So XL stands for inductive reactance. XL is 250 ohms and frequency it is 50 hertz, right? Now the answers are given. Now you know that the power dissipated will be maximum. When is that? It will be maximum when the circuit is in the state of resonance, right? So when resonance occurs, you know that XL will be equal to XC. Correct. So XL, I know the value 250. Now XC will write it as 1 by omega C. Correct. So omega is again 2 pi FC. Right. So frequency they have given 50 hertz. Right. So substitute this frequency here. Right. Now after simplifying the capacitance value, right. So that will be 12.7 microfarad. All you have to do is substitute, right? You'll be getting the answer. So 12.7 microfarad is the correct answer. That is the capacitance, right? Okay. So look at the 11th one. So it says there is a soap bubble of radius 6 centimeter and it has another bubble of radius 3 centimeter inside it. Find the equivalent radius of the soap bubble which has same excess pressure inside it as the 3 centimeter bubble. Okay, so let us sketch a rough diagram here. Now they are saying you have a 6 centimeter bubble, soap bubble, right? Now inside that you have a 3 centimeter bubble. That is radius. They have given the radius. Okay, nice. Now, first let us try to find the excess pressure here. Right, let us try to find the excess pressure here, and they are asking you, there is another bubble, a soap bubble, right? So there is another soap bubble which has the same excess pressure as you see inside the 3 centimeter bubble. What is that bubble's radius? That is the question. Okay, right. Now let us try to get the excess pressure due to 6 centimeter. Now imagine 3 centimeter bubble is not there, right? Now due to 6 centimeter, the excess pressure is given by 4 times the surface tension divided by the radius. So here the answer is also in radius, so let us substitute in 6, let us keep the unit as 6 only, no problem, centimeters only, right? So this is only due to the 6 centimeter. Now consider the presence of this 3 centimeter bubble again, right? So you are getting the excess pressure as 40 by 3 again. So if you had only this 6 centimeter bubble, it was only this first term. Now because you have this 3 centimeter bubble, pressure inside the 3 centimeter bubble will be this. Okay. Now you imagine there is another bubble here whose radius is r. Let me say capital R. Now this soap bubble, it has the same pressure that was present in the 3 centimeter bubble, excess pressure. Okay. So what I'm going to do, I'll equate this to 4T divided, why 4T? Because it is a soap bubble, right? 2 free surfaces, hence I'm getting 4T. So 4T divided by capital R, alright? So you can clearly see that 4T will get cancelled. Now if you take LCM and if you get the answer, so it turns out to be 2 centimeters. Okay. So the correct answer is actually 2 centimeters. So, right, so the correct option is option B, alright. Let us go to the next question. Yes, so it says, yes, interesting question. In silicon semiconductor, pentavalent doping increases electron density. Is it right? Yes, definitely. Then statement 2, in n-type semiconductor, net charge is negative. That is, the semiconductor, n-type semiconductor itself is negatively charged, they are saying. Okay, is it right? No, because you know that when we dope, right? So during doping, what we'll do is we'll take pure silicon, right? We'll take pure silicon and we will add pentavalent impurities like phosphorus, right? So it has pentavalent, so 5 valence electrons, right? Now if you observe the nature, right, that is covalent bonds and everything we used to write. So this is the silicon atom, right? Silicon or germanium you can take, right? Now say I'm adding phosphorus. Now phosphorus, right? So silicon, these are the valence electrons, right? Now you have 5 valence electrons in phosphorus, right? So in that, 4 of them will come here, right? 4 of them will come here and 1 of them will be left as it is. So does it mean that phosphorus atom already had negative charge? No. I mean, that is, if you consider any atom is neutral as a whole, right? So what you are getting is you are getting 1 extra electron, that's all, right? So it doesn't mean that this n-type semiconductor is negatively charged. No, it is neutral. Even after doping, it is neutral, right? So you will just see that, see, you have phosphorus atom somewhere here, correct? So phosphorus atom, it gave, so neutrons, don't worry about neutrons, right? So it has same number of, protons and same number of electrons. Now compared to silicon, that is if I'm talking about the valence shell, valence electrons, right? So phosphorus has 1 extra, that's all. So that will help in conduction, that's all, okay? Right, so statement 1 is true, right? So it increases the electron density definitely, but statement 2 is false, okay? So statement 1 is true and statement 2 is false, all right? So option A is the correct option, all right? So let us go to the next one. So it says 2 identical balls were thrown up at 35 meter per second, yes, and 35 meter per second at an interval of 3 seconds between them. So both of them you are throwing it vertically upwards, right? Now find the height above the ground at which they will collide, right? So interesting question. You can do it in 2 ways as far as I know. So you can take the relative velocity concept, relative motion concept. Then you can take the usual approach, so considering both the balls separately, and you can solve the question by considering the options here. So substitute option A, option B, see which of them verifies, okay? So it takes a long time. So let us see the short approach here, okay? So what you are going to do is, so let us look at the time frame, okay? So at t is equal to 0, you have launched, say, ball number 1 with velocity 35 meter per second. Right, so 35 meter per second. Now say this is the situation at 3 seconds. So t is equal to 0, you have thrown the first ball. After 3 seconds, you are throwing the second ball. Now, in that 3 seconds, what is the height reached? That is, what is the condition? That is, what is the velocity? What is the height and everything? We'll see for this first ball. Okay. So this is the level from where you are throwing the ball. Right. Now, in 3 seconds, this ball went right. So it would have reached some height. We'll calculate whatever is necessary. We'll try to calculate. Right. So you have launched ball number 2 exactly at t is equal to 3 seconds. Again with the same 35 meter per second only. Okay. Now you need to find the height above the ground. So let me take this as the ground level. So this line whatever I have written, that is the ground level, right? So where they will collide, that is what you need to find out. Okay. Right. Now here what I can do is, let me try to find the height reached, right? So height reached by this ball 1 here. Okay. So that is at t is equal to 3 seconds. Okay. Now for that, now my focus is on ball 1. All right. So I can say height reached, right? So I'll be using that equation s is equal to ut plus half at square, right? So ut, right? So velocity is this way, acceleration is down. So let me take, here you can take g as 10 meter per second square. I think it was there in the question. All right. So ut minus half gt square I'll be using, right? So this is 35 into, now I need the height reached in 3 seconds, right? So 35 into 3 minus half into 10 into, now I have 3 square, right? So this turns out to be 35 into 3, which is 105 minus, so this is 5, right? Now you have 9 5s are 45, okay? So this will be 60 meters. Okay, so this turns out to be 60 meters. All right. Now, all right. Now I need the distance, right, where the height above the ground, where these balls will collide. Okay, right. So where these two balls will meet, right? Okay. Now, you know, if you guess the motion, right? If you can feel the motion, so first you will throw ball 1, right? So ball 1 will go up, then you are throwing ball 2. Now at some point, right? So ball 1 will come down, okay? Then ball 2 will collide, right? So something like this will happen. Now here, let us try to observe the motion of ball 2 with respect to ball 1. That is what I was telling here. Let us try to understand, let us try to solve the problem considering the relative motion here. Okay, now V1, so let me write it here. Velocity of ball 1 with respect to 2. Okay, so that, if you remember, that will always be constant here. That is, as long as both the balls are, because you have thrown it with the same velocity here, right? Now for that I need to find the velocity at this point. Okay, that is after 3 seconds ball 1 is here, right? So I need to find the velocity there. So for that what I'm going to do is, let me try to write get the velocity here. It is given as v is equal to u minus gt, right? So 35 minus 10 into 3. So this I'm getting it as 5 meter per second, right? So after 3 seconds, the velocity of this ball is 5 meter per second. Now I'll use the relative motion, that is motion of ball 1 with respect to ball 2, right? Now here, I mean, as soon as these balls lose your contact from your hand, right? So the only force that is acting on them is gravitational force, which gives rise to acceleration due to gravity, right? Now both of them are experiencing the same acceleration due to gravity, correct? Right? So g only, 10 meter per second square I have taken here. So therefore, if you observe the relative velocity, right? So that g, that is, there is no relative acceleration between the balls, okay? Because both of them are experiencing the same acceleration, okay? Now V12, right? So this I'll consider here. So this I got it as 30 meter per second. Now if you observe it here, so this will be true for any time instant. So as long as they are in air, okay. So 30 meter per second I have, okay. Then I need to find, yes, I need to find the time taken now, right? So yeah, so I need to find the height. Now for that, let me try to find the time at which these two will collide, okay? So at that time, now I need to find at what time this ball 2 will meet this ball 1, okay? Right. Now for that, you know, we know the distance now, right? So distance between these two, I have calculated it as, yes, I have calculated it as 60 meters, right? So let me put it here. Now I want you to observe ball 1 with respect to ball 2, that's all, okay? So this 60 meters, they will cover with the velocity, which is 30 meter per second. Remember, this is the relative velocity. So therefore, the time, right, this is given by distance by speed. So now I have 60 divided by 30, which is 2 seconds, okay? Now, in 2 seconds. That is, what was my reference here? So I started my discussion, that is relative velocity, I started considering from this diagram. Okay, so after 5 seconds, starting from here, so it will collide. Okay, now let me see in 2 seconds, right? In 2 seconds, that is from this 3 second moment onwards, right? What is the height reached by this? That is ball number 2, right? Now we know that ball number 2 and ball number 1, right? So ball number 2, it will collide with ball number 1 in 2 seconds. Okay, now let me focus on this diagram here, that's all. Okay, now I need the distance traveled by this ball number 2 in 2 seconds, right? That's all. Now we know that it collides, right, at t is equal to 2 seconds, right? So therefore I'll write it as ut minus half gt square again. Now I have 35 into 2 minus half into 10 into 2 square, which is 4. Okay, 2 square I'm getting it as 4. So this will be 70. Okay, minus, so this is 20. So the height where these balls meet from the ground reference, it is from the ground, it is actually 50 meter. Like I said, I'm focusing on this one, right? So here is the portion, here is the diagram where I considered the relative motion of ball 1 with respect to ball 2. Okay, right. So let us go to the next one. Yes, interesting question here. So it says badminton is in shape of a ring connected with a handle. Okay, so take it as a ring. Okay, fine. Handle, which is a rod. Okay, radius of ring is small r. Length of the rod is 6r, right? So let me take this as small r and let me take this as 6r here. So ignore the handle and everything. Okay, fine. So let us take it as 6r here. Fine. So if the mass of the ring is m, mass of the ring is capital M, and mass of the rod is small m. Okay, mass of the rod is small m. Find the moment of inertia of system about the axis passing from a point r by 2 from end, that is from the handle, you can say. Okay, r by 2 from the handle end, that is from this end. Okay, and perpendicular to the ring plane, so that is the axis is like this now. Okay, it is towards you, right? So let me sketch a rough diagram here, so that will be easy. Now I have this ring here. Fine, so its radius is r. Okay, so obviously this is going to be r. Now I have this handle here, so which they have given it as 6r, right? So this is 6r. Now they're asking you to find the moment of inertia about this point, which is r by 2, right? So which is r by 2 from the handle, that is the end of the handle, right? So this distance is r by 2. So the axis is like this now. Okay, so this is quite easy. Now the mass, right? The mass they have given it as, so let me say mass of the ring is capital M. Yes, mass of the rod is small m. Now here you have to consider the moment of inertia due to ring, moment of inertia due to rod, right? And I think you have to use the parallel axis theorem. Simple. Okay, now let us try to get the moment of inertia at this point due to the rod only. Next we'll get due to the ring only. We are going to add them. Simple. Okay, so finally, yes, what I'm going to get is, right, so the moment of inertia, let me write it as moment of inertia due to ring and moment of inertia due to the rod. Okay, now let me get the rod part first. Okay, now this is the moment of, this is the axis, right? The axis is towards you, right? So where I need to find the, about which I need to find the moment of inertia. Now we know that, yeah, let me get the distance, right? Now I need to get the, I need to use the parallel axis theorem, right? So the center of mass, right? Just focus on the rod now, right? So it is here, right? It is here. So which is at a distance 3r from one end, right? So this is 3r. In 3r, subtract r by 2. Okay. In 3r, if I subtract r by 2, I'll be getting 5r by 2. So this distance, right? This distance, it is actually 5r by 2. 5 small r divided by 2. Let me write like that. Yes. So this is going to be 5 small r divided by 2. All right. Okay. Now, yes. Now for rod, so I have ml square by 12, right? So that is about the center of mass. Now I have m l square. So l I have. So here the length is nothing but 6r, right? ml square by 12. So 6r whole square divided by 12. Okay. Right. Now next, this is due to the, that is I have to apply parallaxis theorem now, right? Still I've got the moment of inertia about the center of mass. Next what we are going to do is plus the complete mass into the distance whole square will do, right? Now mass is again, okay, now the mass is small m, right? Okay, let me write small m here. Yes, the mass is small m, right, small m. Now this distance whole square I have to do, right? So 5r by 2 the whole square. Yes, so 3r, right, it is right. So 5r by 2 the whole square. Okay, 5r by 2 the whole square. This is what I have to do. So I got for rod now, right? I have written for rod. Now let me write for ring. Okay, now the same center of mass concept will come into play here. Now I have this ring here. So the moment of inertia about its center of mass, right? So that will be simply mr square, right? So mass is capital M. Now I have small r square, right? Now from this, right? So that is from the center of mass to this point, I need to find the distance. Now, how will I do that? Here I have r plus 6r, which is 7r. From 7r, I need to remove this r by 2. Okay. Now, from 7r, if I remove r by 2, I'm going to get 13r by 2, right? So, mr square plus m into 13 r by 2 the whole square, right? So if you simplify this much, okay, so the answer, right, I think you can guess the answer. So the final answer you should be getting is this, that is option A, right? So this was quite interesting. You have to consider the rod separately, consider the ring separately, apply this parallaxis theorem 2 times, and finally you have to add them, right? Nice. Okay. So let us look at the next problem. It says a sound source and a detector are moving away from each other with equal speed of 20 meters per second. The detector heard a sound of frequency 1800 hertz from the source. Okay, what is the original frequency released by the source, right? Assume the speed of sound to be 340 meters per second. Now look at the question again. So a sound source and detectors are moving away from each other with equal speed of 20 meters per second. Both of them are moving away from each other with an equal speed of 20 meters per second. So if you sketch the rough diagram, it looks like this. So this is the source and this is the observer. Okay, so this is going away at 20 meters per second. This is also going away at 20 meters per second. So it says the opposite direction, moving away from each other, right? So this is the diagram. Okay, nice. Now, right, the detector heard a sound of 1800, right? When they are moving, right, the detector heard the sound as 1800 hertz. Now, do you think this is the actual frequency or the apparent frequency? This is actually the apparent frequency because the source and the observer, they are in motion, right? So this has to be the apparent frequency. Now you have to find the original frequency released by the source. Okay. Now here we will use the Doppler effect relation that we have, right? So the apparent frequency f dash, let us say, okay, so that is equal to the actual frequency f naught, right? Now I have velocity of sound, SO I have written, okay. Now usually we write like this, right? So plus or minus, now you have for the observer, okay, then you have for the source. This is SO for sound, now this you have for the source, right? Okay, now here two things are happening, that is observer, right? So when you have the observer stationary and if the source is moving away, you will see a dip in the frequency, right? Now if observer is stationary and if the source is moving away, right? So then also you will see the fall in the frequency, right? Here both are happening, right? So therefore we'll write, so f naught, right? So f dash they have given, which is 1800. Correct, f dash they have given it as 1800. Now I have 1800 is equal to f naught. This is what you need to find, okay, right? Now observer is moving away. Now I have 340 minus 20 I have to do, right? So 340 minus 20. Now the source is also moving away, right? Now I have 340 plus 20. Okay, so that is all. If you substitute and find the value of this original frequency, right, it turns out to be 2025 hertz. Okay, so that is the answer. This is the original frequency of the sound which is getting emitted by the source. All right, so that is all for today and thank you. Right, so keep learning, subscribe to Extramarks. All right, so see you in the next session. Thank you, study well.